Hi, everyone. Thank you for joining. This is Caroline Griffin, RIoT's Event and Operations Manager. We are super excited to have you for our last session of Developer Month today. I'm just giving a quick brief intro, and I'm super excited to have Todd Spain here from the Advanced Mobility Collective, Brad Lane from Semtech, James Schaffer, and Mike Marks from Microchip. And this session is sponsored by Microchip, so please stay tuned. We're giving away 2 great prizes today, courtesy of Microchip. So stay tuned for the networking half hour. Just a couple of quick overview. If you have any questions throughout the presentation, please do put those in the chat box. As soon as you think of those questions, just go ahead and put them in there. We'll make sure they get answered either during or after the presentation or during the networking hour. But without further ado, just thanks again to all of our speakers for being here. Thanks to all of you for coming. I encourage you to connect with the speakers and presenters, whether it be during the networking half hour or afterwards. And as always, if you have any questions, please put those in the Q&A box, or you can directly message me and I'll make sure they get addressed. So we will pass it over to Todd Spain from the Advanced Mobility Collective, who is our opening speaker for today. Thank you for being here.
Thank you, Caroline. If you just stop sharing, I will share my screen.
There you go, you should have it, Todd.
There we go. There we go. Is that there?
It is. Thanks so much.
All right. Well, it's great to be here and to speak with you all. And Caroline, I really appreciate the invite and the opportunity to share what's going on in the world of drones and autonomous things flying in the air and moving on the ground. I'm actually, it's not letting me go forward, and we just tested this. There we go. So I'm talking to you from my place out in Colorado, up in the mountains, and I'm quite excited to be here, especially today, because Tom Snyder and a couple of other RIoT folks are meeting with us today in Winter Park, Colorado, and we're discussing bringing RIoT opportunities to the Front Range in Denver and also up here in the mountains. And I'm very, very excited to be working on that today. And this is a photo I took 2 days ago to make you all jealous of how beautiful it is up here. Wanted to point out that where advanced mobility fits in with RIoT. So many of you are aware of the Wireless Research Center and centered out of Wake Forest, and we're all part of this bigger organization. So RIoT is a part, and the Wireless Research Center is a part. We have Matt Bauer a couple of weeks ago spoke about our Connected Communities project that's part of the same organization, and Advanced Mobility Collective is also a part. So we're all really one big happy family, and I think that's really interesting because things we'll talk about later about the convergence of technologies that are happening in our collective world. So this is me, and not too interesting, but I just want to introduce myself. I'm a technology person really, and worked with entrepreneurs for a very long time, and worked with some big companies like Cisco. I'm involved with the Advanced Mobility Collective, and also help the Wireless Research Center and Connected Communities organization with strategic initiatives that we have underway at the WRC. And I wanted to also make sure that we understand what advanced mobility means, because it has a lot of different meanings to a lot of different people. And I'm really proud to say that we spent a lot of time talking about the term advanced mobility. And because of that conversation, NASA actually adapted that term as what they call, they think about things only in the air, so they call it advanced air mobility. But for us, advanced mobility equals interconnected electric autonomous vehicles and systems. So it means the vehicles themselves in the air and on the ground, but also, and way more importantly, I think, the systems that actually tie them all together to make them actually work and provide real value back to the world. I mentioned convergence a little bit ago, and it's just been in the last 10 years or so, this amazing leap forward in connectivity with 5G emerging and broadband that's coming to far-flung places in the country, not fast enough, but it's starting to happen. We have massive, just incredible data capture from the Internet of Things that you are all involved with every day. The amazing sensors and the data that's being captured from that. And there's also a great deal of investment that's happening right now in air and ground vehicles. You've probably heard stories about Tesla and the investment that they're making in autonomous vehicles on the ground, but the same kind of thing is happening in the air as well. So there are around 100 companies right now that are investing in what's called an electric vertical takeoff and landing vehicle. It's basically an air taxi that's a giant drone that will move people and things. And we're not really that far away from that being a common part of our world. And each one of those craft that are being worked on at various stages, the estimate is it will take about $1 billion to get a single craft certified to be able to fly. So if 100 companies are intending to invest upwards of $1 billion, it's an amazing amount of money just going into eVTOLs right now. So all that money and these craft and the connectivity and the data and the sensors that's happening from IoT are turning these vehicles into very smart machines in the air and on the ground. And there are a lot of people, thousands of people that are imagining and thinking about how to bring all of that to reality and do it as quickly as they can. And real use cases are starting to develop now. We're seeing things in healthcare opportunities and with COVID and touchless delivery. And that is all because of convergence that we hope at the Advanced Mobility Collective happens at scale. I don't see any questions, so I'm going to keep rolling, Caroline. COVID itself is an interesting thing. In about March, when we launched the Advanced Mobility Collective in February, and COVID obviously started hitting in March, and we didn't really know what the heck was going to happen. But the truth is that it actually sped up our work pretty dramatically. There's a new urgency for things around telehealth and drug delivery and lab sample delivery and trying to move hospital supplies in and around places. We're trying to figure out how to manage supply chain with human distancing and trying to find ways to creatively transport people and goods. There's home deliveries that sprung up in test markets with that happening. It's speeding new technologies to market, and in a few cases, not a lot of cases, actually lifting some arcane rules from the FAA and other governing organizations. And there's lots and lots and lots of government funding that came as a result of COVID, and much of that, or not much of it, some of that poured into activities that we just talked about. So what if we had a world where we had ubiquitous 5G and broadband all across the country, a big goal of the wireless research centers to make that happen. We had all of the components of the advanced mobility ecosystem were linked together. We were emerging technologies in your world and with IoT. We have Tesla and Google Wing and UPS and other big companies that are coming forward with massive market disruption. And we had autonomous drones transported people and bots on the ground, and local bodies and the FAA and NASA and other organizations were actually coordinated. Well, that's all the stuff, that's a lot of stuff that has to happen to actually realize some of the benefit and the opportunity of advanced mobility. And I think if there's any good news about COVID, it is that it uncovered a lot of problems that we already had. It created a few more, but it also created, like I said, a new sense of urgency toward bringing these technologies forward as quickly as we possibly can and do so in a safe manner. So the collective is an organization that came about a year and a half ago, or maybe 2 years ago now, spinning out really of conversations with WakeMed Hospital in Raleigh. So WakeMed is the first entity in the United States to fly routine autonomous drone missions, which they've been doing for 19 months now, delivering lab samples from one part of the hospital to the lab across the campus, and doing so 8 times a day for 19 months now. And with that, when that happened, UPS came to be part of that, and they were the first entity in the United States to receive their autonomous Part 135 license from the FAA to allow them to be an operator of autonomous vehicles in the air. And it's interesting that happened all right in Raleigh, and there's a lot of other companies that are around the Raleigh area and in Wake Forest and in Wake County and other parts of North Carolina. It's become a real hotbed of activity in this place with the technology folks, with communications people, with IoT people, with forward thinkers in government. And so the collective what really spun out of that soup of conversation. And we decided that we wanted to be a partner and sponsor funded nonprofit, sort of like RIoT. The collective is the idea is to join together technology, business, government, research from all across the far-flung parts of this very new advanced mobility ecosystem, and then find a way to reduce the friction and connect all these crazy components together and actually do real things. We're not an organization to do basic research. We're not an organization to write white papers necessarily. We're not trying to be an accelerator necessarily. What we're trying to do is bring lots of disparate types of entities together and actually go do real things. So we're also trying to do that by shaping the advanced mobility ecosystem in a way that benefits the world, as opposed to a handful of very small, very big companies. And I mentioned before, we're trying to frame real world challenges and link it together and make it happen. We do have a handful of young companies that are new in this world, and they're able to plug in to some of our activities. And so along the way, they are being accelerated and having a chance to participate. We want to make sure that the public is on board with this, and we already are a source of trusted information. For example, with NCDOT and county commissioners and the Triangle J Council of Governments and so on. And we have a role to liaise with the federal, state, and local bodies to inform policy development. A lot of policy needs to happen in order for all of this to eventually grow and take place. There are a couple of people I wanted to point out that are what we call experts in residence. They participate in really critical thinking, and as we're thinking through projects that we want to put forward, and they come from an amazing background. And one of them, some of these folks you might actually know. Kyle Snyder is one. Kyle has been around the urban air mobility world for about 20 years now. He runs robotics for Cherokee Nation strategic programs, but he was part of NC State for a very long time, and really created the seed that became the Advanced Mobility Collective with an organization there he ran called NGAT. And Tom Davis works for Crown Consulting, which is based out of Washington, D.C. He worked for 36 years for NASA, and when he was first introducing himself, he mentioned that he is from Ohio, and his father was an aeronautical engineering professor at Ohio State University, and one of his dad's best friends was Neil Armstrong, the astronaut. And so Tom hung out with Neil Armstrong, and Neil helped him get a job at NASA as an intern, and he stayed there for 36 years and ran the NASA Ames Research Center, and is just one of those people that knows everybody and is highly connected in Crown. A big part of the collective has won 4 or 5 major contracts in the last few months that you may have heard in New York and in other places around the country that are really leaping forward advanced mobility right now. Denny Lewis is a local person in Raleigh, and years in the military, worked in procurement for the Pentagon, and does a great deal of work now with companies that are trying to move into the DoD space. And it might be Denny could be a great contact for any of you that are interested in DoD work. He runs the North Carolina Military Business Center, which is very focused on moving North Carolina companies into opportunities with the Department of Defense. Stuart Ginn, an interesting guy, is a ENT surgeon at Wake Med, but way more than that. He also runs the Innovation Center there, and he's practically personally responsible for getting the drone program up at Wake Med and making that happen in conjunction with a lot of other people at NCDOT and others. And before he became a surgeon, he was an professional airline pilot, and flew for a major airline. So it's an interesting career trajectory for him. Chris Fernando is a consultant, been around this space for about 17 years. He does a great deal of work through a company called HOVCON with the FAA, local airport authorities, and with NASA. And he is just one of those guys that, again, knows everybody and knows how to put together thinking and proposals and that sort of thing in a highly effective way. And it's great to have Chris be part of the experts in residence. We also have an advisory board made up of several more people. One of them I wanted to point out, his name is Jeff Causey. And Jeff runs Causey Aviation and Causey Aviation Unmanned. His organization has been working with Flytrex. They've been flying food deliveries in Holly Springs for a while. If you heard about the Walmart opportunity that's coming up, Causey Aviation is the one that's going to be the operator with Walmart to be able to start doing deliveries with them in North Carolina. And his company, Causey Aviation Unmanned, is going to be the fourth Part 135 certified operator for autonomous vehicles after UPS, Google, and Amazon. So he's in great company, and it's fantastic to have him be part of the collective, because we need an operator to be able to do some of the great work that we're moving forward with. And here's a handful of the partners that are part of the collective. Mentioned Causey Aviation Unmanned, but I'm really proud to have companies like J. Davis, which is a major architectural firm. They do design work with giant, especially urban places like giant office complexes or housing, and they're an amazing part of the collective to be part of that, and especially in conjunction with Stewart Engineering. Stewart Engineering is local to Raleigh, and they have a great deal of experience in designing and engineering the physical type of infrastructure that will be required to land and power up and be able to manage the air to ground transition of packages and people. It's going to be a big part of what has to happen to be able to have routine missions happening with autonomous vehicles in the air and on the ground. And there are a lot of challenges though with advanced mobility, and when I was writing this slide, I was actually kind of feeling sorry for myself, because there's a lot of it. There's a lot of big hurdles to overcome. One of them is that there's a lack of systems thinking. A lot of the people that come into this space come from aviation, or they come from maybe autonomous vehicles, or they come from software, or they come from making investments. But very few people are thinking about this as a multimodal logistics and transportation opportunity. They think about it as, I've got to build sensors that can make something fly better and smarter and avoid things. They think of it as, I've got to create new regulations so that things can fly without running into each other. But not a lot of people are thinking about it from the entire system, and that actually makes something real happen. And we also, the regulatory pace has just been frustratingly slow. FAA certifying vehicles, one of the next steps forward is to be able to have what's called beyond visual line of sight missions, where there's a drone that's operating away from someone that might be with a control panel, where it's truly operating autonomously and away and out of sight of the human that's looking after it. And that should have happened about 1.5 years ago, and it's been frustratingly slow. We also, there's just a very dire shortage of real world use cases and operations. So we're moving past the lab. The one thing that you guys, I'm sure, are very, very well of, there's got to be alternative architectures and new ways of thinking and managing data and data collection and onboard compute. It's going to become a bigger problem as more and more sensor technology is included into the craft themselves. More and more data is passing back and forth from air to air and air to ground and ground to air. And then where is that compute going to live? Is it going to be on the edge in networking on the ground? Is it going to be on the edge and on the machines themselves, the vehicles on the ground or in the air? And like always, there's a lack of funding. There's a lot of funding, billions and billions of dollars going into the vehicles themselves, but almost no money is going in to developing the operations themselves of being able to connect all of these pieces together to again make something real happen. That's something that Advanced Mobility is working very hard to do. And I'll tell you about a project that's moving forward move through this conversation. So I mentioned to you a little bit ago that the notion of multimodal, it looks something like this. This is a little bit complicated, the graphic, but look on top of that building in the blowout. It's a place where imagine an eVTOL, a craft that's flying in the air carrying people or things that potentially a human being is piloting first, but eventually will be autonomous. It lands on a vertiport on top of a building. There are robotics that take a package off and hand it to a bot on the ground, and that bot moves it into that facility, whether that's a hospital or some other kind of building or across town. We have people moving vehicles that are on the ground that are interacting with that, perhaps bringing people to the facility where the eVTOL is going to take off. We have drones delivering packages between buildings and between buildings and homes. There's a lot of things that are happening, and that interconnectedness, that multimodal thing, if you take no message away from today, it's something I really want you all to think about. Is that's what reality is going to look like. UPS eventually is going to have autonomous vehicles in the air that will deliver packages to some kind of facility, that will have robotics that will transfer it to an autonomous vehicle on the ground, that will most likely have drones flying off of that to deliver packages to the door for the last few meters. And it's not a singular air problem or a ground problem. It's a multimodal challenge and opportunity both. And with that in mind, there are some great use cases that are developing now. So especially around healthcare, with moving people, for example, moving a surgeon to a rural place where someone needs attention, to moving a person or persons to doctor's appointments or to the hospital that maybe have routine things that need to happen. And transportation is one of the biggest problems in healthcare today. It's one of the biggest costs. It's one of the biggest limiters to people having access to healthcare. And of course, there's telehealth, where we're moving skilled people where they need to be. We have drug delivery. There's many use cases happening in healthcare, and one of those is developing pretty dramatically in Winston-Salem right now, where they're exploring the opportunity to become the first real place in the country that is routinely flying electric vertical takeoff and landing vehicles, and doing so with healthcare use cases in mind. And we're working with them, starting to work with them now. And then just normal supply chain with transportation of goods. In oil and gas, there's a big opportunity with mobility to move people and supplies from the shore out to offshore oil and gas rigs. And of course, Department of Defense, they're all over this right now. They've created, the Air Force has created a program, if you will, in conjunction with NASA, whereby they're trying to bring civilian style requirements to the Department of Defense to be able to make it easier for companies like all of us to incorporate in and build systems that actually benefit the Department of Defense, but also don't have higher overhead and requirements that would be more demanding than civilian use. So they can get the needs of the Defense Department met and create civilian opportunities and more. And I built this slide just to make it as confusing as possible. These are all of the things that we can think of right now that need to happen to make routine missions. And the things that are above the line are things that need to happen in the air. And the things that are below the line are the things that need to happen on the ground. And the things that are on the left are around design and build and implementation. And the things on the right are around ongoing operations. And I don't have the time to run through all of this, but you get the idea that there's a great deal of work that needs done, from funding to the physical infrastructure to communication systems, edge computing happening in design, build, and construction. We've got to figure out how we're going to operate these multimodal systems and do the data collection and the analytics and manage the physical infrastructure and the operations. There's a lot of stuff. It's kind of an overwhelming thought process. Sometimes when I wake up in the morning, I can't even manage to put it all together in my head. This is a rough timeline and very thoughtfully thought through. But in 2020, right now, we have Part 107 drone operators, people that are manually operating drones, doing drone deliveries right now. That's taking place. They're in test and they're not routine, but it's happening right now. And by the end of the year, we're very, very hopeful that we have the ability to start testing beyond visual line of sight operations in the public as well. We have urban ground vehicles, those little bots on the ground that are starting to be deployed in certain places and certain missions. In 2022, we fully expect to see an expanded unmanned traffic management system that's similar to the air traffic management system we have today managing airplanes. And there's talks right now at DOT about having the first one actually operate in North Carolina that the collective will be part of. We're planning to build vertiports in 2022, these places, these physical infrastructures where drones and bots and eVTOLs will take off and land. In 2023, we expect to have a piloted eVTOL, where there's a human being that's flying an autonomous VTOL that can take over in the event of some kind of an emergency. And then on out, it gets a little harder to predict as you go, but we'll have autonomous trucks and autonomous urban ground vehicles in place in 2024, where they're on highways and on streets and in buildings in a routine way. 2025, autonomous cars in a routine way. 2030, autonomous drones flying ubiquitously, and 2035, maybe even 2030, autonomous eVTOLs flying ubiquitously. So it's pretty exciting what's coming, and a lot of work to get there, but great opportunity ahead. So I wanted to make sure I left plenty of room for questions, and Caroline, I'll let you kind of help me dictate how you want to handle questions.
Thanks, Todd. Wonderful presentation.
Thank
we
you.
do have one question here, and I encourage if anyone else has questions for Todd, please put those in the Q&A box. But Todd, great information. Are you also looking at MAVNet? Oak Ridge National Lab has MAVNet, which is a beyond visual line of sight communication system for unmanned vehicles.
I have barely even heard of it, so no, we're not working with them yet. And I'd love to, if you've got something that you can help me get to them, I'd love to make that contact.
Thanks. Conrad put that in the.
So Conrad, I'd love to have your help on it for sure. That's pretty awesome.
Thank you, Conrad. A question here from Lee. Have you used RTK?
RTK, I don't know. I don't even know what that is. So what is it?
Lee, if you could share a little bit more about RTK. If not, we can get you connected to Todd. Todd, what's the best way for these attendees to get in touch with you?
Well, the one way is Todd at amc.org, and I'm on LinkedIn. Pretty easy to find there, and would be happy to connect on LinkedIn with anybody here. And as I mentioned, I'm in Colorado, but I'm back in North Carolina on Saturday and plan to spend the next few weeks catching up. And so if someone wants to have a socially distanced coffee, something like that, I'd be happy to get together and talk if there's opportunity for us to help each other out.
Wonderful. And I did put Todd's email address in the chat box, so please feel free to connect to him there, or as he said, via LinkedIn, or always you can reach out to me, Caroline, and we'll connect you. So those are all the questions that I'm seeing, Todd. Just great presentation. Again, if you think of any questions, please shoot them over to Todd at amc.org. We really appreciate you being here, Todd.
Yeah.
Thank you so much. And up next, we have Brad Lane from Semtech. So we'll give Brad just a minute while he's getting set up with his slides. Again, if you do have any questions throughout the presentation, please do put those in the Q&A box. We'll make sure those get answered either during the presentation or afterwards. But without further ado, I will let Brad, Senior Field Applications Manager with Semtech, he is up next. Thanks, Brad. Brad, it appears you're still on mute.
Thanks, Caroline. And thanks for the great opening session from Todd. That was quite interesting. So my name's Brad Lane. I work for Semtech Corporation. I'm based out of Tampa, Florida. I support customers across kind of the eastern half of the United States, and spend most of my time working with customers on IoT type of applications, and specifically LoRa. So LoRa is a technology that Semtech helped invent, and LoRaWAN is an interoperable network protocol that is actually owned and controlled by the LoRa Alliance, which is an open industry alliance we'll talk about more. So for today, there's really great opportunity to kind of get a comprehensive understanding of LoRa, LoRaWAN, and actually how to get an endpoint connected. So in my presentation, it's kind of broken into two parts. The first part is a high level kind of intro to LoRa and LoRaWAN, really more from a ecosystem, business landscape and application perspective. That will take me probably about 20 minutes to go through. And then from there, I'm going to go into a much more detailed training workshop session that will kind of explain, more of the physics around chirp spread spectrum modulations. And what I think is particularly important for maybe a lot of the folks on the phone is to really understand how LoRaWAN networks work and the different options for you to go, deploy a network or use a network. And as much as the LoRa modulation technology has a lot of advantages, the flexibility in network architecture and distributed networks, I think is just as interesting. So, I think that section will have a broad appeal. And then one of our partners, Microchip, who's licensed the LoRa modulation technology, we'll pick up a final session starting at 11, and Mike Marks will take you through a hands-on example of how to actually get a LoRa radio endpoint connected to the Things network with a gateway and so forth and so on. So hopefully by lunchtime, everybody will have a really clear picture of how LoRa can help solve problems and how to go maybe start experimenting and building a solution. For starters, I suspect some of the folks on the call now are familiar with LoRa, have heard about LoRa. For some of the folks, it still may be new. There's actually been, in the last few weeks, a lot of LoRa-related announcements from significant partners. So you guys can go Google around on LoRa and find some really cool stuff going around with neighborhood networks and decentralized networks that are being offered by a number of our partners. But to take a step back from that, when you say LoRa, we're really referring specifically to the chirp spread spectrum modulation that Semtech invented. And this specific modulation basically allows the longest range, most robust RF communication when you consider factors like low power and operating in the ISM bands. So LoRa is a new fundamental modulation technology that's been introduced into the market. And it's really was optimized, invented from the very start to address what I'll call this IoT sensor problem. And by that, what I mean is for the IoT, value proposition, all the great IoT business ideas to actually be deployable, you need, hundreds, thousands, millions of very low cost, very low power sensors and actuators. And it turns out that the other RF technology that a lot of us are familiar with and use every day, although it can function in those kind of use cases, it really wasn't optimized from the start to solve that problem. So, obviously we're all familiar with cellular, and the fact that your iPhone or your Android device can now stream HD video while you drive down the highway. I love it. I'm a big football fan, but that's not necessarily the most optimized modulation RF approach to extend battery life. So we all know we have to charge our phones every couple days, right? So if you're deploying a sensor in an agricultural field, you need the battery to last, 3, 5, 10 years. Although cellular, solves a certain class of problems, it probably wasn't the best solution for low power sensors. The cellular industry is obviously responding to the IoT market need. And, they have Cat 1 and NB-IoT protocols, which definitely close the gap with LoRa. But again, they're always constrained by the fact they have to be interoperable and backwards compatible with the broader cellular networks, which their primary goal is to let me stream movies and games faster. So I think you'll see in terms of power, coverage, link budget, all of those types of things that LoRa will continue to optimize in the long range, low power, low cost space, and just be able to continue to outperform a lot of the cellular solutions. We love cellular from a LoRa perspective because we think it's an ideal technology to put into LoRaWAN gateways. So as we talk about LoRaWAN network architecture in the second half of the presentation, I think that'll become clear that LoRa takes advantage of not only cellular networks, but also Wi-Fi networks or traditional IP, Cat5 type networks extensively. And we use that infrastructure as the main pipe to backhaul all the data from that we collect from the sensors. But really that architecture makes a ton of sense because we can really optimize the sensors and the gateways specifically for this IoT problem, right? Of hundreds, thousands, millions of sensors that need to stay connected reliably, across any deployment scenario. Obviously, I think Wi-Fi it kind of is even a clearer example where we want meshed Wi-Fi routers in our house and business because we want to walk around with our laptop and phone and have video conferencing capability like we're having today. Wi-Fi again is trying to optimize for some lower power solutions, but just constrained by the fact that they also need to be interoperable for the high bandwidth. And again, I think you'll always see that LoRa, purely focused on low power, long range, will have an advantage there. BLE in terms of low power performance is the closest competitor to LoRa. But again, BLE was really intended to be a personal area network. It's great to connect your phone to your headset or maybe a mouse or something, in that kind of scenario. But BLE does operate at 2.4, which inherently is a crowded spectrum. It also has a physics disadvantage versus sub-gigahertz technology, which LoRa supports. And also just from a protocol perspective, in addition to having a reliable RF link, you really need a network architecture that's scaled to manage hundreds, thousands, millions of devices. And BLE doesn't really isn't provisioned for that. It's not the problem it's trying to solve. So again, we think LoRa is a unique technology. It's offering a best-in-class performance for a lot of these IoT applications. And honestly, it's a complement to Wi-Fi, cellular, and BLE. I think anybody who's spent any time in the IoT space knows that to deploy full stack solutions, it's going to be a multi-fusion of technology and communications protocols, so forth and so on. Just to summarize some of the specific advantages of LoRa, again, very optimized spectrum. So just to put that in context, a LoRa device can transmit up to 250 bytes at a time. It has equivalent data rates, somewhere in the 1 kbit per second to up over 30 kbit per second range. But that's not enough bandwidth, to stream HD video and things like that. So we're really optimized on sensor data, actuator data, those types of things as part of the IoT solution. As most people may know from maybe if you took a communications theory class, there's a relationship between data rate and sensitivity, which translates into maximum range and link budget. So low bandwidth and long range complement each other, and one of the reasons LoRa has the best-in-class range and indoor penetration is because we've made that trade-off. Again, we'll cover more of the technical background on this in the second half of the presentation. Very low cost. The silicon itself is multi-source, licensed from multiple suppliers. LoRa predominantly operates in license-free ISM bands, although it can be used in licensed bands as well. And there's a lot of press out there about outdoor coverage of LoRaWAN. But I'll say from working with customers on a daily basis, probably half of my customers are really using LoRaWAN for indoor coverage and penetration. We have lots of customers deploying LoRa into hotels, restaurants, retail stores. And all of those scenarios, there was Wi-Fi in the building, or that they had BLE sensors in the building, and they came to LoRa because if you have a large retail store, you need to put in one gateway and cover the entire place, or maybe two gateways if you have a multi-story hotel, things like that. And LoRa just simply provides the most comprehensive indoor coverage with the lowest infrastructure cost that you'll find. When we talk about LoRaWAN, which is the networking protocol that sits on top of LoRa, That was defined by the Alliance, which Semtech helped found, but we also had, great inputs from companies like Cisco and IBM who really understood IoT. They understood IoT before the rest of us were talking about it. And because of that, they've developed a MAC layer architecture that is really elegant. It scales to millions of units, and it doesn't have some of the manageability limitations of other things like maybe Zigbee or Z-Wave or BLE. Gateways are stateless in a cloud managed network. That means there's very little local configuration. There's no keys at risk in the gateway itself. The LoRaWAN protocol is very lightweight. That means it can be run on low cost, low power microcontrollers. It supports cloud-based as well as edge kind of hybrid deployments. So we'll cover a lot of this in detail in the second half of the presentation, but it's the combination of the LoRa 5 performance and the LoRaWAN network architecture that's really kind of making LoRa and LoRaWAN the de facto low power, long range standard for IoT. As I mentioned before, we really see cellular and Wi-Fi as complementary network technologies. We think that they are used extensively and are the right technologies to continue to use in LoRaWAN gateways. We've worked closely with a number of those industry alliances, and there's a number of white pages on our website that I would encourage folks to go read. That talk about 5G synergy and Wi-Fi synergy and corporate network synergies with LoRaWAN. For anybody on the phone who is in the IoT space and is actually deploying solutions, I have a pretty confident that this slide will resonate with you. It's easy to come up with an IoT demo and get it running in your workshop or your office. But when you start thinking about deploying that demo across all of the different types of customers you have globally, in a lot of cases, I think you can summarize those challenges in this slide, right? You can go put a single gateway at a single site, and that's great for some applications, but a lot of times, when you're selling to your customers who maybe own multiple sites, it's Five Guys or McDonald's or whoever the chain restaurant is or the retailer is. You have to figure out how to deploy and manage this IoT solution across multi-sites. Then you have the problem of large physical sites where one gateway can't talk to all of your sensors. So, this would be, a large corporate campus or college campus or school campus are great examples. Like, you need to easily be able to deploy gateways and have them automatically work together and reinforce each other. And then, the final situation is when you talk about, global logistics and asset tracking, you need multi-site, multi-network roaming. So you need to seamlessly be able to transition from communicating on a private, LoRaWAN corporate network potentially to a public LoRaWAN network managed by one of the public network operators like Senet or Orange in Europe, and then possibly back into your customer's LoRaWAN network. And so one of the the hidden gems with LoRaWAN network architecture, it's really the only IoT network architecture that has been provisioned to allow this flexibility for devices to move across networks managed by different entities. So increasingly, and again, I think if you search around for some of the recent announcements about neighborhood networks and decentralized networks, you'll find some really great stuff about LoRa. But we see this kind of matrix of emerging IoT networks that are out there. So as much as the LoRa radio technology is a huge differentiator, LoRaWAN's ability to work and flex into these kind of different combinations of deployment and network scenarios is one of the big reasons we're getting a tremendous amount of traction with enterprise and corporate customers. In the LoRaWAN network space, and if you go to the LoRa Alliance site, you can look for a comprehensive list of all of the public network operators. So there are companies across the globe building cellular-like public LoRaWANs. Senet would be a good example. They actually have coverage in Raleigh. So if you go check out the Senate site, you can look at their coverage and their options. So you can basically get a LoRa endpoint and join that Senate network, just like you kind of would get a a Cat1 cellular device and join a cellular network. However, LoRaWAN is completely open, and it runs in the ISM bands. So it's very easy for an enterprise to decide to run a LoRaWAN network at all of their locations and facilities. And as we talked about before, because of the way LoRaWAN network architecture scales, it's very easy to do that and have a distributed IoT network that I can run across, my chain food restaurant or my retail restaurant or my warehouses. LoRaWAN supports endpoints kind of roaming between these two entities with no reconfiguration of the endpoint. And then you have this emerging consumer neighborhood network, LoRaWAN. So if you look at the Things network or maybe some recent announcements by Amazon, there's all kinds of interesting things of, letting putting a pet tracker on my pet. And if he, runs out the door down the street, he can still communicate through a gateway that's in my neighbor's house. And due to the security and network architecture, the LoRaWAN networks enable this type of roaming. So combining all of these together is a really unique thing that LoRa and LoRaWAN are bringing to the IoT space. This is just a summary of kind of the LoRa Alliance. So again, I encourage you guys to go to the LoRa Alliance website. It's been one of the fastest growing industry alliances, technology alliances over the last few years. We pretty much have all the major, technology providers, Semtech and Microchip from a semiconductor perspective. You have Amazon and AWS and Azure and all participating within the LoRaWAN ecosystem. So if you go to integrate and build your full stack IoT solution around LoRa, pretty much at every level, there's an integration partner or integration example that's been worked out. And we'll go into more detail in the second half on the technology there. Just a summary of kind of how big LoRa is, in the world today. So Semtech, launched LoRa 5 or 6 years ago. Since that time, we've shipped over 145 million LoRa endpoints. There's 157 countries that have what I'll call a public access LoRaWAN network that's out there. So you can access it as network as a service. There's, pretty much every country has private LoRaWANs in it today. And then, we're over 800,000 gateways, I think quickly closing in on over 1 million gateways that are out there. So, LoRaWAN's not what I would call, it's not a kind of new early adopter technology right now. It's kind of transitioning out of that into becoming, kind of the mainstream de facto IoT network technology that's out there. Just a summary, again, of all the countries that are covered with LoRaWAN with some form of a public access network. So, it's pretty much all the major countries. There's a few outliers there, but, we're quickly closing in on having a global network architecture. Just a snapshot on LoRaWAN network architecture that we'll go into a lot more detail on, but it is a long-range star. So sensors predominantly talk directly to gateways, and gateways talk to sensors. My comment always is, you only use a mesh protocol when you have to. And not that mesh protocols don't bring a tremendous amount of value to a lot of applications, but they also come with some overhead and unpredictability in terms of network coverage. So I think, there's a lot of support academically that if you can deploy a long-range star network, it's a little bit more deterministic in terms of figuring out, how to cover a site, and it's not dependent on maybe intermediate nodes or collectors that have to reinforce the network and relay messages, and the number of relays degrades your effective throughput and so forth and so on. So a lot of our customers had come from a mesh world, and when they've come to LoRa, they just really appreciate its simplicity and the ability to really predictably cover buildings or improve coverage simply by adding a gateway and not having to do any more reconfiguration. So what's shown in the slide here is that multiple LoRaWAN gateways that are using the same network server for the network management and intelligence automatically work together. So if I added another gateway to this diagram, I wouldn't have to go do any real reconfiguration, re-key provisioning or anything like that. Everything would just continue to work, and your QoS would go up because you have more redundancy in gateway coverage. Likewise, if one of these gateways goes down, the other two gateways automatically will pick up, assuming that they're in range of the endpoints, and continue to operate. So you could have a gateway go down or replaced without necessarily losing network coverage and losing precious data. LoRaWAN gateways are designed to work and together and leverage IP network connections. So as long as those LoRaWAN gateways share an IP connection to that network server, whether it's Wi-Fi, Ethernet, or cellular, they'll automatically start to work together. And that ability to scale like that and virtually scale, those gateways don't even have to be in the same location. So you could have a distributed network architecture with a gateway at, again, each restaurant you own or each warehouse you need to put a system in. And they become a virtual IoT network that you can centrally manage via the network server. LoRaWAN basically has the concept of an application server. And a lot of our partners have basically built bridges from the LoRaWAN application server into more standard IoT technologies like MQTT and HTTPS. So it's very easy to integrate into an existing back-end AI system that a customer may have, and kind of merge this data that would flow in with LoRa into that existing infrastructure. Or if you want to build it from scratch, you really can leverage platforms that some of our partners have built and very quickly get something up and running and deployed. Semtech and is committed to make sure that LoRa is multi-sourced at every level. We think every customer out there wants choices. So from a silicon perspective and SiP perspective, Semtech, ST, and Microchip all offer LoRa-enabled silicon for sensors, endpoints, and actuators. Again, Mike Marks will go over their platform as a follow-on to this morning's session. There's also off-the-shelf FCC certified modules from Murata and Laird and Multitech. So there's a bunch of options there to get folks started and to prototype. We also have a big ecosystem of sensors and industrial grade water meters, electric meters, moisture sensors. That full catalog of sensors that is out there is one of the broadest in the industry for IoT. And because of the LoRaWAN standard, any of those sensors that you buy that are LoRaWAN compliant, you're assured that they can work with a LoRaWAN gateway and a LoRaWAN network server. So that interoperability and the ability to mix and match sensors from leading suppliers is one of the big advantages of LoRaWAN. You're not locked into any specific vendor for a gateway or a sensor or even the silicon. The gateways again are multi-sourced from Cisco and Tektelic and Laird. You can also go build your own gateway. So on the Semtech website, there's a reference design. You can look at the SX1302 and Corcell. There's a full reference design and full software examples for gateways that are in the public. So again, LoRa is open at the gateway level. From the network operators and network server perspective, as I mentioned, a LoRaWAN network does need a network server. So there's companies that provide that as a software package, either as software as a service or as a licensable piece of software. So OrbiWise and LoRiot and Actility are the leading providers of commercial network server software. You also have folks who are running networks, and these could be commercial networks that are like cellular or like a neighborhood network in Senate and the things industries. And then there's a completely open source network server option with ChirpStack. So again, for customers that want to build everything from scratch, or you want to build a self-contained LoRa network that runs on the edge, Everything is here documented, lots of ability to mix and match across the different components. From an application enablement perspective, we've got pre-integrations with, all the major cloud partners. And then, there's some innovative startups like Tago.io, which is a Raleigh-based startup that has a really great application dashboard platform for customers to use and quickly get up to speed on. So if you have any questions about this or follow up, you can get with me or Mike Marks, and we're happy to connect the dots across this to get a solution package together for you to start to test with. Just to summarize this first section, and then we'll dive into the more technical material. These are the key attributes of LoRa that we think stand out versus other IoT technology. Longest range, deepest indoor penetration. That's always connected to the power. So, lowest power solution, that achieves that long range and deep indoor penetration. Infinitely scalable, very cost effective. It uses unlicensed frequency spectrum. The silicon itself is simpler, lower cost than other networking options. It is bidirectional. So all endpoints are bidirectional. They can transmit and receive. It is a global standard. It does also work while moving. So one of the advantages of chirp spread spectrum, unlike maybe an extreme narrowband FSK, is if you're driving down the highway, LoRa works fine. So maybe back to Todd's presentation, there may be some use cases, or there are some use cases in autonomous vehicles and so forth and so on. It is secure from a LoRaWAN perspective. It has basically two layers of AES encryption, which we'll talk about more. And one of the key aspects of LoRa is our ability to provide locationing intelligence without a full GPS device, which I'll talk about more in the second half of the presentation. There is, software-wise, everything in LoRa is open source. So you can go to the LoRa GitHub and get endpoint stacks, gateway stacks. You can go to Chirp Stack and get a full LMS. So there's nothing about LoRa that requires a license from a software perspective. In terms of use cases for LoRa, we really started with a focus in smart utility. Water meter globally is the largest, I believe, deployed end use case for LoRaWAN. But that's quickly grown into basically every type of industry, as I think the people on this call probably would represent, that IoT is everywhere. It's not just smart city, smart utility, smart building, right? Smart environment, smart healthcare. COVID has opened up, like Todd was mentioning, COVID has accelerated LoRa deployments, and there's a number of COVID-specific solutions that look at occupancy detection, people density detection, people temperature detection, so forth and so on. So LoRa is touching pretty much every aspect of the global economy and society. Just a real quick, again, I won't go into detail on these, but if you guys want to look at do some searching on the internet, there's some white papers that go into detail. Birds is a company out of Europe that has transitioned to LoRa and LoRaWAN for water meters, water leak detection. Water utilization and water efficiency continues to be a global problem, and it really hasn't been managed well from a technology perspective yet. So smart building, Capgemini is another company that has solutions for meeting room, desk occupancy, so forth and so on. Particularly I think COVID has made every business that owns a physical building reevaluate how that building's used today and will be used, and you can't do that without data providing intelligence. And so LoRa-based sensors for occupancy are one of the fastest growing use cases that are out there. Axino solutions, cold chain tracking. I think we all care about food safety. I think everybody's heard the stories about some restaurants that had salmonella problems or other types of contamination. So the restaurant industry was traditionally low tech, and not only that, the whole supply chain for the food industry, from farm to table, was very fragmented, was manual logs, so forth and so on. So there's a bunch of solutions and companies out there that have automated different aspects of cold chain and have deployments across major retailers and food distributors. So Axino Solutions is one of those. Compliance Mate's another, Globe Tracker's another, that are really connecting the dot on, you know, a completely monitored cold chain and using LoRa sensors. One of the reasons that this wasn't automated before is a refrigerator, particularly a commercial refrigerator, is like a Faraday cage. And it's very hard to get RF transmissions out of that refrigerator. And, you know, LoRa was really the game changer for that industry, where you could put a low power, you know, battery life 3 to 5 year sensor into a refrigerator and then transmit that temperature data out reliably, you know, to a gateway sitting, you know, in the basement where the cable modem is at the restaurant or the warehouse. So it's a great success story, and continue to see a lot of momentum there. You know, again, commercial water. So we have a number of companies that are doing wastewater for commercial buildings, wastewater for hotels, water heater monitoring in hotels and commercial buildings, just to make sure we're being efficient with the water and the energy spent on heating water. Agriculture, again, is a huge area for LoRa. Obviously, if you could get a gateway up on a 100-foot grain silo, you know, out in Nebraska, you can literally cover, you know miles, 10, 13 miles of radius. And that makes it just incredibly efficient to go in and add, moisture sensors or pest detector sensors, or, those types of things into the agricultural fields to make sure we're being efficient with water and resources. The other area that we're seeing a lot of traction is asset management, and particularly tracking assets within manufacturing facilities themselves, or supply chain of manufacturing as devices move across facilities. I think a lot of people are familiar with RFID here. And obviously, LoRa, again, we're not going to replace cellular, and we're not going to replace RFID, but we complement those technologies. So doing active beacon LoRa asset trackers inside of factories is a really large and fast growing use case. Increasingly, Semtech is adding more intelligence to our devices. So at the very end of the presentation, I'll talk about the LR1110 device, which is a single piece of silicon that integrates Wi-Fi, a GNSS receiver, and LoRa. And so, using that fusion of that RF information, we're able to get a more precise location than using any one of those technologies alone. So I think active beaconing, active RFID, are areas, again, where you're seeing a lot of LoRa momentum in the industry. And again, it's a combination to our low power and the ability to have a very low infrastructure cost. So to light up a fairly large commercial warehouse, I might be able to do it with one gateway. Right, and no other RF technology really gives me that ability to cover that much space with such a low investment in infrastructure cost. Oops. Just a final comment about Semtech. Please check out our website. So we do sell a portfolio of Semtech radio parts, and we also sell the chipset for the gateways. Again, we are kind of the source of the IP around LoRa, so app notes about LoRa modulation, FCC compliance, ETSI compliance, all of those things you'll find on the Semtech website. We also do run a development network server if customers want to come, look at testing that. And we have recently launched a cloud services arm, which basically provides some management services for these IoT devices. So that includes managing the device health metric. We do a cloud-based locationing algorithm. And in the future, we'll be doing things like helping with photo updates to devices. So please take a few minutes and go check out the Semtech website. So I'm gonna stop here for just a minute and see if there's any questions on this first section. And then the next section, we're gonna go into some more technical depth on the chirp modulation and the network architecture.
Thanks, Brad. We do have a couple questions here. I'll just read them out one by one. We'll go from the bottom. The first one is, do you create custom dashboards for receiving LoRa data?
Semtech does not, but our partners like Tago.io do. And there's another company called My Devices Cayenne, which I think Mike will show in the afternoon. So we have a number of partner ecosystem companies that provide what we call the dashboard or application server solution to a LoRaWAN product.
Thanks, Brad. Next question here. First, a comment. Great presentation, Brad. Thanks. Are these white papers available on your website?
Yes, so we will make the presentation slides I'm showing today available to everybody who joined the RIoT event. And if you check out the Semtech website, the white papers on like LoRa modulation, most of those are found under a product. So you can look at an SX1272 or an SX1262 and find, detailed white papers on, FCC compliance or ETSI compliance or modulation link budget. There's also an awesome tool called the LoRa calculator that you can download from our webpage, which allows you to calculate a link budget for any specific LoRa transmission, as well as model the energy consumption of that transmission. So if you're trying to simulate battery life, those are some great utilities that you'll find. We also have the LoRa developer site. So there's a dedicated site, at Semtech you can register for LoRa developers, and all of those resources are there as well. But there's a forum, an interactive place to connect with other folks looking at LoRa technology.
Perfect. That's really helpful. Thanks, Brad. Two-part question here. I'll start with the first one. How is support in LoRaWAN for OTA updates of sensor nodes?
Yeah. So obviously, a lot of us come from an embedded space, and you need to do firmware upgrades. So LoRa does support firmware over their upgrades. If you look at the LoRa Alliance site, specifically with LoRaWAN, the LoRaWAN standard is moving forward and has already published some of the underlying libraries that you need to do large-scale FOTA updates. So as folks may know, in any RF situation, and particularly in LoRa, you have to fragment your FOTA binary into a lot of little pieces and send it down and reconstruct it. So for example, there's a standard and a library for fragmentation, defragmentation that's been published. If you want to do updates, you have to possibly change the mode of operation of the device from what's class A to class C, which I'll talk about in the next section. Yes, so the answer is you can do FOTA over LoRaWAN. Today, it's not automatic. You shouldn't assume that every LoRaWAN device, you can just click a button and do a FOTA. But a lot of our customers are building solutions that support the FOTA application. And increasingly, Semtech and the Alliance are working to simplify the work that needs to be done to get FOTA to scale across hundreds, thousands, millions of sensors.
Thanks, Brad. The second part of the question was, what about LoRaWAN gateway firmware update management?
Another great question. And I'll cover this a little bit in the second part of the presentation. So the LoRa Alliance specifies the protocol interaction between a LoRaWAN gateway and a network server, but it never specified a specific networking connection besides an assumption that it was an IP connection. And historically, there's been a reference piece of software that Semtech developed called Packet Forwarder that has been the base of the developer gateways and networks. But a lot of our commercial network partners have taken that and created a proprietary version. So for example, Senate or Actility has a proprietary implementation of that link between gateway and network server. And with that, in some cases, they have also provisioned for remote gateway management and remote gateway firmware upgrades. However, those are specific to your network provider. So you would need to, if you're using Senate or Actility, you would need to work with them on that specific implementation. Semtech has recently released what we call Basic Station. So Basic Station is Semtech's proposal to kind of modernize and hopefully standardize that interface between the gateway and the network server. There's a secondary part of Basic Station called CUPS, which is a remote gateway management utility based on a standardized protocol. So the answer to the question is, in some cases, depending on the gateway OEM and your network provider, there is the ability to do that today. In other cases, it would be left up for the customer to implement that based on some references that exist in the ecosystem. And similar to FOTA, Semtech is working to try to standardize this across LoRaWAN gateways, but we're in the early stages of that, and so customers can get Basic Station and start to work with it, and we'd love to work with more customers and gateway partners to get that moving faster.
Thanks so much, Brad. Last question I'm seeing here is Class A passive onto the endpoint?
Class A passive onto the. So a Class A device is an Aloha device. It can talk to the network literally whenever it wants to. After a Class A device sends a message, if it's a confirmed message, it needs to stay awake and listen for the RX1 and RX2 confirmations, which also provide an opportunity for the network to send a downlink to the device. So I'll cover this in more detail. So maybe I'll just leave it for better explanation when I have the slides up to go through it.
Perfect. Thanks so much, Brad.
All right. So oh, is that it? Okay. Let's get started into the more technical session here. Hopefully it sounds like we got some great interest. Hopefully everyone will find this beneficial. So just the the agenda. I'm going to give a quick primer on modulation technology. Right, this is not an RF engineering class, but like I said, there's great app notes on the Semtech website that really go to that next level of detail if you want it. I really want to spend more of my time here on item 2 because I think a lot of customers on this call, what you guys really care about is how do I deploy a LoRaWAN network and make it work cost effectively, reliably. How do Class A, B, and C work, those types of things. So I will go a little bit faster over the modulation technology and spend more time on item 2 and 3 here because I think for folks in IoT, that's really what they care about. For those of you, with engineering backgrounds, everyone's familiar with spread spectrum modulation. It has huge advantages. We use it every day in our life with our other wireless devices. And traditionally, there's 3 types of spread spectrum out there: direct sequence spread spectrum, frequency hoppy spread spectrum, time hopping. So LoRa specifically introduces chirp spread spectrum, which is kind of a variant of these fundamental technologies. But LoRaWAN actually employs a frequency hopping scheme on top of the chirp spread spectrum. So chirp spread spectrum it's been around for a long time. It was originally used in radar systems. So academically, this approach goes back a very long time. What Semtech did was really the first company to realize that chirp spread spectrum was an ideal modulation approach for IoT. And we have some specific IP around the implementation of chirp spread spectrum that enables very low cost, very low power types of devices. But chirp spread spectrum uses a frequency change over time. We basically code similar to other spread spectrums, redundancy into a series of chirps that represents the bits that we're sending, right? So a really simple maybe way to think about this, that it turns out that like a lot of things we learn from nature, a bird chirp is actually using this frequency variable frequency signal, and that's why it sounds like a bird chirp. And it turns out that one of the reasons birds do that is that using that chirping signal, it makes it easier to pick up even in very noisy environments. So I'll play the second clip, which you can hear the bird in the background with a bunch of construction equipment. If I can get it to work. So you can see it, hopefully here in that second clip, you can still pick out the bird chirp even in the presence of noise that is actually at a higher decibel level than the bird chirp. And that's a great analogy. I mean, obviously this is audio band versus RF band, but it's a great analogy to why LoRa works better than other approaches in the RF space. And if you did an audio representation of a LoRa chirp, it would sound like this. So definitely sounds like something out of a 1950s sci-fi movie. But it turns out that this ability to take advantage of this variable frequency chirp pulse to encode data is one of the the core secrets to LoRa and why it works. This is really a summary of what's in the app note of mathematically why LoRa works better. So if you look at the chart on the left, you can see the Shannon capacity boundary. This is basically a law of physics on Earth, right? That's the limit in terms of sensitivity versus data rate. And you just can never go past that. You can see traditional or the other industry standard modulation approaches like GFSK, which before LoRa kind of represented the best in class compromise between data rate and sensitivity, are significantly below LoRa at any point on the chart. This also shows the physics relationship between data rate and sensitivity. So, this is why LoRa is inherently low bandwidth and Wi-Fi is not, right? But this is why LoRa gets tremendous range and Wi-Fi doesn't, right? It's just the physics of the world we live in. The other, thing I'd like to point out is if you look at the chart on the bottom right here, where it shows the narrowband signal. So, the other kind of RF modulation approach to getting very long range is typically to go very narrowband in your transmission to get rid of as much noise as you can by filtering. So narrowband RF, definitely is widely successful today, but it has limitations as well. And specifically, any narrowband FSK type of transmission, you have to have a signal above the noise floor to recover it. And one of the great things about spread spectrum is we can actually demodulate signals below the noise floor. So it's a combination of all of these things that really give LoRa modulation its advantage in terms of not only, theoretical point-to-point range, but practically, the reliability of that modulation in factories and warehouses and, water meters that are buried underground. Right, so this is just kind of a summary of all the benefits of LoRa modulation. And again, if you refer to the white paper on our website, it kind of goes more into the academic mathematics of all of this. But it's all, this is all known. Chirp spread spectrum modulation, again, was defined 100 years ago, and the mathematics are well understood, right? It's really bringing that to the market with low cost, low power devices, and then a network architecture that takes advantage of it. RF 101, all RF transmissions, including LoRa, are subject to attenuation. So, people like to ask me all the time, well, hey, what kind of range am I gonna get with LoRa? Well, where are you gonna put, where are you gonna deploy this at, right? Because every building is different. Every site has different attenuation. So although LoRa will generally do better than other modulation in terms of range of penetration, we're not gonna transmit directly through a mountain either, right? So, think about this when you think about deployments, and because every IoT deployment is different, you probably need to do some site survey estimates, just to get a feel for how LoRa works. What I will say, just to give reference examples, there's lots of examples I have where customers get miles and miles of range from LoRa, assuming they have some level of line of sight, whether that means across the water or if you have a gateway in a high vantage position, like on the top of a grain silo, 8, 10, 12 miles in Nebraska is pretty common. In Raleigh, Senate actually has a gateway on, there's some towers on the south side of Raleigh by Gardner, that radio towers that are way the heck up there. And Senate has a really high LoRaWAN gateway up on that tower. And I drove around the Beltline in Raleigh and was getting LoRa signals, all the way up off 70 there by Briar Creek. You're not getting 100% coverage from one gateway, but that just gives you examples of getting tens of miles of point-to-point range from a LoRa gateway. If you talk about like a building example, we have people are putting one gateway in a restaurant and covering the entire restaurant, no problem. When you talk about multi-story campuses or buildings like that Semtech building, a lot of people are putting 2-3 gateways in those commercial-sized buildings and getting 100% coverage with some redundancy. So, you really do need to test for your specific application. There's variability here in location of gateway, how strong your endpoints are in terms of transmit power, but, the laws of physics do apply. you can't transmit through a mountain with LoRa, right? So this is a basic link budget calculation. And really, what I would say here is, all of the RF devices that you find from Semtech or from the other silicon providers, we're all using basically the same process nodes. We're using the same implementations of LNA and PAs and things like that. So, what LoRa really brings to the table here is the improvement in efficiency of RX sensitivity, which we talked about on that previous slide. And mathematically, you can go look at the numbers and validate. But to come up with your link budget calculation, you take the TX, all the attenuation and gains across the transmitter and the receiver, and you come up with a link budget number. Routinely LoRa link budgets for real deployments are over 140, over 150. You can get into the 160s. And that LoRa calculator I mentioned on our website would give you an exact number for any specific configuration or scenario. We talk about free loss space, and again, there are well understood attenuation values that you guys can go look at. And again, if you're deploying in known environments, you can calculate some attenuation and do some site survey or site estimates for any RF system, including LoRa, right? But you would take our higher sensitivity level, and getting an extra 10 dB or of sensitivity has a huge effect on range, right? Because you can kind of say maybe you double your range for every 3 or 4 dB, right? And so getting 10 is a massive increase in range. To just calculate the actual attenuation, again in a practical situation, typically you'll buy a LoRaWAN endpoint that's 20 dBm output power or 30. You start there and you basically go down, and then you add back in your sensitivity, and you come up with a calculation of can I realistically communicate using LoRa modulation. You can Google again this out there. There's a lot of people who've used LoRa in weather balloons and even now low orbit satellites. So the pure line of sight calculation for LoRa based on link budget is in the hundreds of miles. It's not just 10 miles. It's you get into the practicality limits of attenuation with trees and buildings and curvature of earth and things like that when you talk about land-based ranges. The one thing I will say that's not accounted for in the link budget calculations is really the effect of multipath and fading. And it turns out with LoRa, because the sensitivity is so high, we actually are able to recover quite a few reflected signals. And in some cases, the reflected path is the higher reliability path for LoRa. So, the fact that LoRa signals bounce around a bit, is actually a positive thing. And if you look at some of the field studies we've done with multi-gateways, or if you deploy a system with multiple gateways on a campus, you can actually see that the LoRa signal a lot of times is getting to, 2, 3, 4 gateways. And within the LoRaWAN protocol, it handles all the deduplication of those packets. But that packet redundancy is huge in terms of helping the overall QoS of the LoRaWAN network, be much higher than other alternatives that you see. The other really powerful aspect of LoRa is what we'll call spectral efficiency and interference immunity. So one of the attributes of the chirp spread spectrum modulation is that I can have 2 transmissions at the exact same time, at the exact same frequency. And as long as those transmissions are using different spreading factors, right? The spreading factor is how the data is spread across different chirps in the chirp spread, in the CSS modulation. Both signals can be recovered at the same time. They don't interfere with each other. So this is a big advantage to LoRa in terms of, one of the questions we get asked is how many LoRa, transmissions can I have a day? Or should I be worried that there's another LoRa-based system near me and, that there's going to be too much interference coming from that other system? And again, the physics says that there is a true limitation in terms of spectral capacity. But in practicality, I haven't seen customers reach it yet, right? And one of the reasons is that LoRa networks are highly adaptive dynamically. and they use different spreading factors and a frequency hopping scheme. So by combining, different spreading factors with a true aloha transmission pattern with the orthogonality of being able to demodulate two transmissions at exactly the same time, as long as they use different spreading factors, gives us an incredible amount of spectral capacity. The other aspect of LoRa is its ability to even recover a signal when you do have a collision. And this is specifically a scenario where I have two transmissions at the same time at exactly the same frequency that are using the same spreading factor. So in that situation, as long as one of the two packets reaches the gateway or the receiver with a 6 dB stronger signal strength, we can still demodulate that packet. And so this leads us into the next slide, which is incredibly important, on why having multiple gateways in a deployment really dramatically enhances your overall network QO success, your packet success rate, dramatically increases the overall packet capacity of the network, and allows even for fewer collisions. So if you look at this diagram, it basically shows 3 gateways here in the center, right? And then represented here at the intersections of the red and blue arrows are theoretically 2 endpoints that are transmitting. So as we talked about, if those endpoints, and because of the link budget, those transmissions normally from those 2 endpoints would hit all 3 gateways, which is great because that gives me a lot of redundancy. But let's say there's a very rare event where these 2 endpoints actually do transmit at the same time and on the same frequency. Again, if they were using different spreading factors, the gateway B would have no issue recovering both signals. But in the even rarer event where they happen to use the same spreading factor, what this slide is showing is that there would be a collision at gateway B. However, because gateways aren't all in the same place, and the attenuation of an RF path to any 2 gateways is unlikely to be exactly the same, what it's showing is that the transmission from the sensor on the bottom would likely be recovered by gateway A, and the sensor from the represented by the arrows here at the top would likely be recovered by gateway C, because there would be that 6 dB difference in signal strength of those transmitted messages across the gateways. So this aspect of combining the benefits of LoRa modulation with aspects now of the LoRaWAN network architecture are really kind of the pieces of the puzzle that come together to give LoRa just kind of best in class performance for IoT, whether it's outdoor or indoor. In terms of LoRa PHY and packet format, you can actually you look at this on an O-scope or a signal analyzer. There's a preamble, there's a header, there's a payload. Again, all LoRa devices can be used with just the LoRa PHY. If you don't want to use LoRaWAN and you want to go do a point-to-point deployment with LoRa, totally capable of doing it. The LoRa devices basically support all the way down to 150 megahertz up to a gigahertz in one family of parts. And we actually do have a 2.4 gigahertz family of LoRa devices too, called the SX1280. So we have a significant number of customers that are not using LoRaWAN, and they are just using LoRa modulation for improved link budget and low power for lots of different applications. If you want to use LoRaWAN, the LoRaWAN standard defines a very specific packet format and encryption and authentication, which we'll start to talk about in the next couple slides. Key features, this is a LoRaWAN transceiver product. It's kind of the bread and butter radio that Semtech sells for a lot of these sensor endpoints. Basically, to this, you need to add a microcontroller, or you could use like the Microchip part, which integrates a microcontroller and a similar radio into a single chip. But it looks like a standard low power sub-gigahertz radio. So if you've used a part from TI or Scilabs or somebody else, it feels the same, looks the same. From an RF impedance matching perspective, it's very similar. What's really different is you have this additional modulation mode that allows you to kick in the LoRa modulator. All of these products also do support FSK, so they can be multi-protocol. we have lots of customers that are running legacy utility protocols or security system protocols in addition to LoRa. You just have to manage that with the microcontroller application time. A typical design basically has a microcontroller and a radio. And again, it looks kind of like this. In the case of like Microchip's product, it combines these two elements into one package for you. This is just a quick look. And again, you can look at the data sheet or the LoRa calculator of what we call the spreading factor, how the spreading factor affects the chips per symbol, and then how that affects that demodulator, SNR, and sensitivity, which are really, again, the secret sauce to the LoRa Phi layer performance improvements. We've talked about this before, and I'm about to ready to go into more detail on it. LoRa is along LoRaWAN now. When we talk LoRaWAN, we're talking about that specific network architecture implementation. It is a long-range star. Sensors talk to gateways. We have this network server and application servers. So we're going to dive into this in detail in the next few slides. This shows a breakout really of what happens in the LoRaWAN network server, which is really important. And this is where the kind of the secret sauce is to enable, kind of these public, private, hybrid network deployments, and how do you keep everybody secure, and how do you make sure that there's not a security risk to your network, right? So end devices basically are pre-provisioned with a secret key. So we use a symmetric encryption, AES encryption. And that secret key for the device needs to be registered with this element called the join server. So the join server basically controls what devices can join a LoRaWAN network and which ones are not allowed to join the network. And so for the join server to process a join request message from an endpoint, that endpoint's unique identifier, which is called the dev UI, needs to be registered in the join server. So the dev UI is like the physical MAC address of every device, and it's required by the LoRaWAN standard to be unique per an IEEE block of addresses. There's also a unique identifier in the device that's called the join or app UI. And that identifier really has a dual power. It basically tells the network server which join server to route the join request to. Again, in hybrid network architectures, this join server may not be maybe run outside of the guy running the network server. So we'll talk about that more in a little bit. And then there's a secret key that's pre-programmed into the device, and a secret key that's pre-programmed that needs to be registered with the join server. So when the network server gets the join request message, it forwards it to the join server. If it can identify the dev UI, the join UI properly, and the key is registered, the join server will encode a join response message back to the network server, gets sent back down to the endpoint. The endpoint will then try to decode that message and basically validate that the join server sent down a properly encoded message. So as part of this process, the end device and the join server both derive session keys at the time of the join. And assuming that the credentials of the device match the credentials that were pre-programmed or pre-registered in the join server, those session keys should match. And it's only in that instance that the endpoint can decode the join accept message and realizes that it does have a secure connection to the join server. All of this is there to prevent replay attacks and other types of IoT security risks. After the endpoint has successfully processed the join accept message, it can start sending messages up to the network. Those messages basically have two layers of encryption. There's encryption on the entire message itself that uses the net session key. And then there's a separate layer of encryption just on the payload. And that's important because, again, if you were sending messages over a network that you don't own or run, like a public network like Senate, or maybe your partner's network that's running it in a retail store, you don't want necessarily that network operator to be able to decode your payload. So as part of this interaction between the network server, join server, there's also an element called the application server. And it turns out that this join server gives the network session key to the network server, but they give the app session key only to the application server. So that way, the person who owns the end device and maybe owns the data coming from the sensor can protect that payload as it's delivered to their actual IoT backend. In this diagram, this application server could actually be run outside of this network server. So the company that owns the sensors could actually own and manage that application server in their own cloud. In some cases, in a lot of the development examples, what happens is you're actually letting your network server partner, whether this be Senate or the Things Network or somebody else, run an application server, and then they basically put a bridge on that data using MQTT or HTTPS to let you access it just to ease development and maybe be a more compatible integration flow. But the key messages from this slide are that the LoRaWAN is a very secure network technology. It hasn't been compromised, in part because of its simplicity. The one key that you guys need to do to maintain that security is make sure you protect the integrity of the key that's pre-provisioned in the endpoints and needs to be registered in the join server. And one of the ways to do that is actually add what we'll call a hardware secure element to the silicon. So Semtech's latest device, the LR1110, has that built in, and I think Mike from Microchip is going to talk about their solutions for that as well. So that's probably a follow-up session that we'll cover in more detail. But the other aspect of the slide that I want folks to walk away with is that you can securely transmit LoRaWAN data over somebody else's network. And the reason for that is there's two encryption keys, the network session key and the app session key, which are handed out by the join server. And there's all kinds of ways for you to basically protect your data as it flows through a public network or maybe a partner network scenario. The flow that we just talked about was OTAA, which is defined in the LoRaWAN spec. It's called over-the-air activation. There is a method to bypass that and basically have hard-coded network session keys. It's called AVP. And there are some reasons why that will make sense. There's probably too much detail to go in today, but you can look at the LoRaWAN specification and you basically hard code devices with the network session key and the application session key and bypass the OTAA process. That may make sense in private networks. It may make sense in some type of devices that only transmit like 10 times because they have a really tiny battery. Like there is some stuff done where if you open a delivery box, you have a little LoRa active beacon in there that sends out like 10 messages just to let them know the box was opened and delivered. So some of those use cases, that makes sense. LoRaWAN supports 3 modes of device operation. Class A is by far the most common, and all devices start as Class A. So a Class A device is a true aloha device. That means that the endpoint can, after it's joined, can wake up anytime and just send a message on a random assigned channel and using any of the LoRaWAN modulation parameters that are available to it. This is best for battery powered devices. The downside is the network can only talk to the device after the device checks in. So if for something like a door lock, maybe Class A doesn't work because you want to be able to do a remote unlock. The other mode of LoRaWAN is continuous. So in this case, the LoRaWAN device acts like a Aloha device. It can transmit anytime it wants, but the network assumes the device is always listening. And that's critical, for like a door lock or a water shutoff valve or something like that, where the network needs to, immediately send a message to the device and have it unlock the door or shut off the water. The problem with a Class C device is battery power. The RX receive current of our radios is very low. It's in the single-digit milliamp range. But if you look at small batteries and long lifetimes, that doesn't get you to 5-10 years of life. So the intermediate option here is what we call Class B, which is a beacon mode. So this is kind of a compromise between Class A and C, and basically the device wakes up at a pre-programmed interval defined as a ping slot by the LoRaWAN specification and listens for a message. But in terms of the market that's out there today, the most common mode of operation right now is Class A. followed by devices that are either Class C or toggle between Class A and C. And then Class B is there for these some use cases like sprinkler controllers and things like that, where you need the device to wake up on a 5-minute interval or 2-minute interval or whatever it may be to check for a message to reduce that actuator latency. This just shows LoRaWAN network type kind of flow diagram. So this shows the Class A device sleeping all the time, gets it into a very, very low power states, microamps of power. So these devices can last years and years and years. The endpoint decides when to wake up. And one of the great things about LoRaWAN is there's no timing synchronization required between the endpoint and the gateway. So it's true aloha after the device joins, and the device can wake up and transmit on one of its assigned channels to the gateway. And it will use a random channel, and it will use an acceptable link budget spreading factor combination that really optimizes the network. After it sends its uplink, it can go back to sleep. Or if it's a confirmed uplink, it will wake up and listen for an RX1 or RX2 downlink from the gateway, which is an acknowledgement that the message was received. This is also the opportunity for the network to tell the endpoint, hey, I've got more information for you. So if you want to send updated parameter information or a command down to a Class A device, you just have to wait for it to send a message first, and then you have the opportunity to communicate with it on that downlink. The network server also sends MAC commands down, like that will recommend a link budget, which ties to a data rate recommendation in LoRaWAN. It could tell it other types of information as well. So there's a list of MAC commands that the LoRaWAN specification defines that allows the network server to stay in communication, synchronized with the devices. A Class C device, as we talked about before, looks almost identical to a Class A device, except for you assume that the endpoint itself never sleeps. So that's why this is red and not green, because we're having to leave our receiver on all the time, which is, again, single milliamp current consumption versus microamp current consumption when we can go into sleep with a Class A device. But the uplink sequence is identical, and then again, it stays awake and listens for the confirmations on the RX1 window, but it basically is always awake. So the RX2 window is always active. So at any time, the network can contact a Class C device and say, unlock the door, shut off the water, turn on the lights. The middle ground is the Class B. And basically this shows that the device stays asleep and then wakes up on a predefined RX window, which happens at some periodicity defined by the ping slot definition in the LoRaWAN spec. So this would work great for things like sprinklers. You want all the sprinklers to turn on, and they check in once every few minutes and see if they need to turn on or not. This is a summary for North America. There's on the LoRaWAN website, there's a regional parameters document that defines all the data rates channels for all the global regions, including Europe and Asia, China, and Brazil. This is the summary of North America. So you can really see here the equivalent data rate in terms of bits per second. What I find is a lot more meaningful to most customers is looking at how many bytes they can send per packet. So what's important here is to see that with LoRaWAN or LoRa in North America, you can send up to 242 bytes in a single transmission. To get the maximum range, you can only send 11 bytes. So for some customers where they say, hey, 11 bytes is just not enough for efficiency, they decide to basically deploy a network based on link budgets that are not based on data rate 0, but basically data rate 1 or 2. So that allows them to send 50 bytes or 125 bytes at a time. Electric meters are a great example here of how you can fit full 3-phase information into a 53-byte packet. So really, the important thing is LoRaWAN absolutely supports this, and you don't have to change anything. All you need to do is densify your gateway deployments so that you have a link budget that supports the data rate 1 link budget versus the data rate 0. So you lose a few dB. You can go to the LoRa calculator and calculate exactly how much link budget you lose from data rate 0 to data rate 1. But if you need to send 250 bytes at a time, that's fine. There's no issue with LoRa. You just need to model your network to basically support a data rate 3 network. You just densify your gateways basically to support these higher minimum link budget data rates that you need for your application. LoRaWAN does support adaptive data rate, and this is generally recommended to be left on. There's a bit in the endpoint that defines whether adaptive data rate is enabled or not. And so it's really up to the customer and whoever wrote the application for the endpoint to say, yes, I want to let the network manage my data rate. This is generally encouraged, and the public network guys sometimes require you to enable adaptive data rate because it does have an impact on the network spectral capacity and how much data traffic it can have. But this just basically shows that as the link budget is monitored by the network server has an algorithm that runs and will automatically recommend endpoints to move to an optimal data rate. That reduces the on-air time and the battery consumption of the endpoint. It also increases the overall spectral capacity, spectral efficiency of the network. Because obviously having endpoints transmit at higher data rates, which has them on air less amount of time, leaves more spectrum and more processing capability in the gateway to process more messages per day. There's a detailed app note on FCC ETSI compliance for LoRaWAN, so I will not go into detail on this, but basically LoRaWAN does use multiple FCC definitions in both the endpoints and the gateways. But this is very well understood now, and if you have any questions, you can feel free to get with me or the guys from Microchip, or we have a number of consultants that we work with that help customers get through FCC certifications. In North America, the channel plan for LoRaWAN is 64 channels. So basically, there's a tremendous amount of uplink capacity. It is an asymmetric channel plan. Again, this is because the IoT problem typically means I have hundreds, thousands, millions of sensors. I need to get aggregated, data aggregated up to the cloud. So I need more uplinks than downlinks. This is a great example of why LoRaWAN is fully optimized for IoT, and other network protocols maybe not so much. There are 8 downlink channels defined in North America. You can notice that the uplink and downlink frequencies are in different parts of the spectrum. That's very intentional. So the total transaction capacity across the spectrum is millions of messages per day, on the order of 8 to 10 million across all 64 channels. Because of that incredible capacity, most customers are actually deploying 8-channel gateways. So when you go look for a LoRaWAN gateway, and most commonly the low-cost gateways like the Things Indoor Gateway or the Gemtech gateways will be 8-channel gateways. And so basically what that means that they're covering only 8 of the 64 channels at a time. And an 8-channel gateway in most use cases can support million messages per day. Depending on the configuration of data rate and confirmed, unconfirmed, it may be 500,000, or it could go up over a couple million. So I've rarely ever run into a customer that has a capacity problem with LoRaWAN transactions. So, but people ask, like, how many endpoints can I deploy on a single LoRa gateway? That's not really the question. The question is really how many packets per day can my LoRaWAN gateway process? So you can say around 1 million, and then you figure out how many endpoints you have and how many times they're going to transmit per day, and that would give you a rough calculation of do you have enough bandwidth to deploy your use case. Also, 8-channel gateways can be centered on any of the 8 subbands. So if you had some rare situation where you were seeing interference from another LoRaWAN deployment with an 8-channel gateway, you can just move it to a different subband. And the gateways and the endpoints are all configurable to move to these different subbands. So you can find a clear space in the ISM bands. One thing to note, and again, we don't have time to go into detail on today, is that the gateways are based on a separate silicon chipset. And it's really a 3-chip combo from Semtech that provides like a software-defined radio chip and then 2 analog front ends. What's important here is to understand that the software-defined radio chip is basically listening on all 8 channels all the time. So this is one of the reasons why we can have that pure Aloha protocol, and one of the reasons why LoRaWAN endpoints get better power consumption than other technologies. The endpoint does not have to check in and time synchronize with the network at all. And it doesn't have to relay anybody else's message. So this is what gives LoRaWAN endpoints the ability to 5, 10-year lifespans for a lot of these applications. I just want to revisit, this comment I made earlier about multiple sites, and being able to, as an IoT solution provider, be able to deploy to any network scenario. So these were the different combinations we talked about before. A single site with a single gateway, multiple sites. So I have own chain restaurants across the country, and I need to have a virtual IoT network and put one gateway in each chain restaurant. I need to cover a campus or a school. So here I need multiple gateways that work together. And then, we talked about the roaming situation. So to deploy a network into a single site, all you need is a LoRaWAN gateway. And in this case, a number of the LoRaWAN gateways that are out there will run a local instance of the network server. So like the Multitech gateways will do that. The Kerlink gateways, I believe the Laird gateways will do it now. So basically, it's very similar to deploying kind of a localized Wi-Fi system. You get a gateway, you power it, you have to register the credentials of the devices in that gateway, and then you can choose to connect that gateway to a local network or not. Or, we have people deploying things like this in the rainforest and they just log the data, right? So very flexible, full edge kind of deployment solution, no dependency on cloud. However, with one configuration change in the gateway, I can redirect the gateway to a cloud-based network server, and that allows basically me to start to scale the network and centrally manage it. So to make that change, all I do is reconfigure the gateway to packet forwarder, and now I have my network server running in a centralized cloud location, whether it's in my server farm or as a software as a service, and I can start to see all the data and manage all the devices remotely. That becomes really powerful, as I said, when I have a multi-site deployment, particularly one that's geographically distributed. So now I can start adding gateways to all of these different sites, whether they're my customer sites or sites I own, and all that data will be centrally managed by my instance of the LoRaWAN network server. And that's really powerful, right? And allows people to deploy globally very quickly. What's even more powerful is the fact that I could either use somebody else's network, and as we talked about, because there's 2 keys, there's the network session key and the application key, I can allow my data to securely go through my partner's network or a public network and get routed back to my application server or dashboard in the cloud. Or if I deploy this network, I can now let other companies, partner companies, or look at this as a way to monetize my network investment, let that traffic run over my gateways, and I will securely send those partners their data because they have a unique encryption key for the payload that will be delivered by the joint server to their infrastructure. So this flexibility in terms of having LoRaWAN gateways be able to process not only your traffic, but partner traffic, or to allow your sensors or your IoT solution to deploy over somebody's network, is really some of the, kind of the secret sauce of why LoRaWAN is becoming the de facto standard of IoT. We've talked about large campus as well. The other great thing about LoRaWAN is if you look at deploying gateways across large campuses, you can just add a gateway to a campus and it will automatically start to reinforce the network. There's really no local configuration provisioning of the gateways themselves, and the keys are not stored on these gateways. So from a corporate security perspective, you don't worry that somebody can compromise the integrity of the IoT network by stealing a gateway. There's really nothing in the gateway itself that provides a hacker anything of value. So if my campus expands and they build a new building, I just go deploy a new gateway and everything continues to work as it is. So it really eases the deployment and administration of a LoRaWAN network. Just a real quick snapshot again of solutions from Semtech. So this is a standard transceiver. These are widely available, stocked globally. And you can add your microcontroller to this and deploy a LoRa endpoint very, very easily. As we said, everything's open source. So you can go get the LoRaWAN stack and download it and implement it. There's lots of reference examples out there. So Mike Marks is going to go through a hands-on session on this very quickly as a follow-up to my session. Semtech does offer a bunch of radios that support LoRa. As you can see, they support a bunch of different frequency bands. This basically covers all of the sub-gigahertz frequency bands that are out there globally and supports all of the ISM bands. We also have a 2.4 gigahertz LoRa part called the SX1280. So if you do want to be in 2.4, you do get higher data rate at the compromise of range. You also get the advantage of being a single frequency for global deployments. So talk to me if you're interested in a 2.4 solution. My final slide is Semtech did recently release a new device called the LR1110. You can check it out on our website. And this is a device specifically optimized for asset tracking and real-time locationing. So it's a full LoRa transceiver like we talked about before, but it also adds a passive Wi-Fi scanner and a partial GPS solution. So it's a GNSS scanner that can receive nav messages from GPS. So anytime you talk about locationing, you're really talking about a fusion of different RF technologies, whether it's BLE beaconing, Wi-Fi locationing, GPS, triangulation with LoRa. So this device in a single device that's very low power, very low cost, combines three of the most popular. We give you kind of the ability to resolve a GPS position. We give you an integrated Wi-Fi scanner, and you get the full LoRa transceiver. So to use this device, you would use a cloud-based resolver that actually returns a lat-long position to you. The rationale for this kind of part is low cost, low power integration into a single piece of silicon, and allows you to really do kind of hybrid indoor-outdoor locationing for all types of different asset tracking, pet tracking, kid tracking. So if folks have follow-up on this, please get with me. My email address will be on these slides, and we're happy to spend more time and show you some demos. There's also a website for this device you can read some app notes on. So with that, I'll wrap up and see if we have any questions.
Thanks so much, Brad. We do have a couple of questions here and lots of positive feedback, including part 2 was excellent, great presentation. The first question is it possible to have international devices like a multi-band tracker?
Absolutely. So again, LoRa devices, we have families of parts that support sub-gigahertz and 2.4. So one of the use cases where customers are looking at 2.4 is international trackers. So you can look at the SX1280 in that case. But in the subband space, because there's more network coverage in sub-gigahertz LoRaWAN, we do have companies that have built what we call tri-frequency products. So the chips themselves, as you saw from that chart, support all the global frequency ranges. But as you go from Europe to the US, 868, 915, you have to decide on, kind of an optimized propagation path and antenna. And then when you go to China specifically and a couple other regions, they're in the 490 megahertz band. So our devices do support dynamically switching between all those frequencies. There's just a little bit of devil in the detail and implementation, but we absolutely have customers doing it.
Thanks, Brad. This next question, I believe, came in during your SF collision slide. Is there a limited number of spreading factors?
Yes, the spreading factors are defined in the data sheet. So you have SF, 6, 7, 8, 9, 10, 11, 12. And so each of those basically adds more redundancy at the expense of delivered bits per second in payload. So yes, and it's in the data sheet, and the LoRa calculator is the easiest tool. Just download it from our website, and you can put in any combination of spreading factor, bandwidth, frequency, and see exactly on-air time, energy consumption. It's a really powerful tool.
Thanks. Next question, is there a preference on antennas, or is there a way to alter the antenna on the endpoint to enhance the transmission? Yeah,
so from an antenna perspective, LoRa acts like any other RF technology. So basically, we have the same issues as another 915 radio. So again, probably don't have time to dive into optimized antennas for for that specifically, but whatever optimization or antenna choices you had for an FSK 915 radio would be the same for LoRa.
Thanks, Brad. Next question. What is the network impact if my packet length exceeds the current data rate defined maximum? And then,
you basically have to break up your transmission into multiple packets, right? So the chips themselves will limit you based on the modulation settings to how much data you can stuff in the packet. There's also some of the limitations are actually FCC dictated. So like in North America, you have a 400 millisecond on-air time limit. So in theory, you could do a longer transmission at the higher spreading factors with the lower data rates. But depending on if you're an ISM band or license bands, you just have to look at making sure you're not violating an ETSI or FCC requirement. I hope I answered that question.
perfect. Thanks so much, Brad. Those are all the questions I saw, and if I missed any, we'll make sure to get back to them.
Okay. All right. Well, thanks everybody. I hope this was helpful. Check out the Semtech website, the LoRa Alliance website, lots of good information, and I will share my slides with RIoT to send out to everybody. And I'm going to turn over to Mike Marks.
Thanks so much, Brad. Wonderful presentation. Up next, we have Mike Marks and James Schaffer with Microchip. So I will let them go ahead and set up their presentation.
All right, thanks, Caroline. I've got is my audio okay?
Sounds great to me.
Okay, thanks. So I'm going to turn my video off just to preserve some bandwidth here in the office. But if you have any questions, hit them in the chat. So let me share my screen. All right, just a quick check. Are my slides on the screen?
They are. Thanks, Mike.
Okay. All right. Well, thanks. And Brad, every time I listen to your LoRaWAN overview, I always learn something more. So great overview. It's a great reason why LoRa and LoRaWAN are becoming great IoT solutions. So if we didn't have the COVID situation, we would be doing this live, and we'd have a number of eval boards and people actually doing hands-on and seeing how easy it is to get a LoRa device connected up through Things Network or any other type of network server and into the cloud. But we'll try to do it virtually for you guys today. So just a quick overview of Microchip. A lot of you may know about Microchip, some of you don't, so I'll just give you a quick overview. We're about a 5.3 last year $1 billion company. A lot of you may know Microchip from the old PIC microcontrollers. We still make those. But now from a perspective, we have bought Atmel a couple of years back. So now we have AVR and PICs. We have a number of security devices. We do power over Ethernet. We have network timing solutions. Very diverse portfolio. We have atomic clocks, actually. We do a lot of the network timing between the cellular networks is controlled by some network timing devices that were part of the Microsemi acquisition. So we're in a lot of different markets. We're in industrial, automotive, consumer, communications, aerospace and defense. And we still have 3 IC fabs in the US. So we still have fabs in Tempe, Arizona, Colorado Springs, and Gresham, Oregon. So we still fab some of our devices locally here in the US. So from a Microchip wireless solution, we kind of cover a lot of the technology. We have Bluetooth audio, BLE devices, a number of Wi-Fi solutions. We do some ISM band radios, 802.15.4, Zigbee, LoRa that we're going to get into more detail. We do keyless entries. We have some voice and audio processing that for doing Amazon Alexa or Google. And we actually even do medical hearing aids and implantable RF for the medical industry. So very diverse wireless portfolio. But today we're going to talk about our SAMR34 LoRa family, and it's both ICs and modules that we have just recently announced. And so basically the R34 family is one of the lowest power LoRa technologies out there. We use a very low power Cortex M0 device, and we've had certified chip down designs. We have modules that are certified. The LoRaWAN software stack that Brad kind of talked about, we actually own that and support that as well. And then we have the Microchip and the old Atmel studio development environment for getting development code written, debugged, and products to market. So this is a kind of a snapshot of our new module that we just came out with. Relatively small size, 17 by 13 by 2.8 millimeters are the dimensions. And then going kind of around the module, there's actually an RF switch in there to switch between either the 868 for Europe or 915 for the US frequency bands. Got a UFL antenna connector. The device in the SAMR34 is actually the SiP. That's kind of the heart of the module. We'll get a little more detail on that. And there's also an integrated TCXO. So basically, this module is everything you need to create an end node or end device. And we'll talk a little bit more detail about the SAMR34. So as I mentioned, it's a very low power Cortex M0. Backup, it's about 790 nanoamps. When you're in standby mode with standby low power battery or SRAM, it's about 1.4 microamps of power. The memory, we have 256K of flash. About half of that is used for the LoRaWAN stack. So that leaves you another 128K roughly for your own application, and a lot of SRAM, about 40 kilobytes. And then there's also a number of peripherals. So depending on what type of sensor you're trying to connect or data you're trying to get, we've got a mega sample per second ADC. We actually have a full speed USB on board, and a number of serial type communication devices, UART, USART, I2C, SPI, LIN, etc. And then this is the system and package part. This is the Semtech radio that Brad went over. So this is the Semtech die that's on part of this chip on board package. And Brad's kind of already gone through all the details of this device. So that's kind of our module. And the other thing I want to mention is we've certified this FCC, IC, and RED for over in Europe. So it's a completely certified module. So just to, like I said, I want to show how easy this is. It is a complex environment. You've got sensors, you've got the microcontroller, you've got radios, you've got your firmware, you've got the LoRaWAN software, you've got development tools. So from Microchip perspective, we try to make it as simple as possible. So there's no finger pointing. We own and maintain the LoRaWAN software. We have certified reference designs that can get you to market. I'll go in a little more detail, but we offer some RF design and support. We own the chipsets and we own the compiler. So it is truly a one-stop shop to get you to market as quick as possible. And I think Brad had a similar slide up there. So, just at the low levels, we support a lot of the major ISM bands, US at 915, Europe at 868. AS 923 is the Far East, kind of Japan, Malaysia market. AU 915 is Australia, KR 920 is South Korea, and IN 865 is the Indian market. So all the ISM bands are supported. We are currently at 1.02 of the LoRaWAN standard. I think we're about ready to release 1.04, so that should be coming out fairly soon. But as we move up in the stack, LoRa modulation is all handled by the Semtech radio. And then Brad went into detail of our Class A and Class C sensors. We do not support Class B in our device, but we do provide all the LoRaWAN Mac software. And then, as I mentioned, you've got about 128K of flash available for your own application, whatever you want to implement. So that's kind of the LoRaWAN support that we provide. And a lot of times from a design trade-off, it's like, do we want to do chip down or do we want to do a module? And here again, we give you both solutions. Obviously, you can get its lower unit costs if you do the chip down. You can maybe optimize your design, do whatever you need to do. But if you need to get time to market is more important, the module is there. And we offer the design tools and resources you need for either one of these solutions. So it's really up to the client to decide, you know, how they want to implement their LoRa design. As I mentioned, you know, we have a number of design resources. These are all on our webpage. You can go to the product information, and as other presenters, I'll forward these slides to Caroline. She'll be glad to get them out so that you have all these links. But we provide schematics, BOMs, layout Gerber files, all in Altium if you need that. We provide some app notes for doing RF design, some PCB layouts. We provide a bunch of radio commands for, you know, when you have to do your FCC certification or, you know, put it in CW mode. And then we also have the Microchip RT tool, which allows the user basically configure and evaluate and test an RF system. So this kind of gives you the behind the curtain on how to control the RF for when you're doing testing and debug. And I mentioned the RF support and layout design review. Actually, this is a free service that Microchip offers. You basically go online at this website, you create a support ticket, and you pass your design files on. And we'll have an apps engineer review those files for you and give you feedback on the design. And there's actually checklists on our websites that'll go through and make sure you follow design guidelines and you got the right number of bypass caps, etc. So all that's available on there, and that checklist is kind of something you use as part of this design service. And you know, it's not an overnight service, so that's, you know, it can take a couple of weeks. So, you know, plan accordingly. Don't have your design ready and say, hey, I want to get this checked, but I need it tomorrow before I make my PC boards. Plan a little bit for a couple of weeks. But we also are actually offering a fast track service for a small, you know, a fee that will get, you know, it turned around in a couple of days. If you want to pay some additional money, we'll bump you in the priority queue. But this is a great service for validating your design and make sure it's good before you go off and get circuit boards made. So that was just kind of a quick overview. I'll just stop here just in case there was any questions, Caroline, that came up on the device family or the module before I kind of get into the hands-on demo.
No questions that I've seen yet, Mike. If anyone has any questions, please do put those in the chat box. We'll make sure they're answered.
Okay, thank you. So like I said, I wish we would have been in person to go through this. It's a lot more interactive, but we'll try to do a live demo and go through what we're going to do. So if you were in class, you would have you know, had one of our SAMR34 evaluation boards. We actually have two of these now. This is one with just the chipset down. And on the module, there's you know, a couple reset buttons and just a control button. We got a couple headers for option boards, and one of the option boards we're going to use for this class is just our little IoT explain board, and it's got a light sensor on it, so we can get light sensing readings and a temperature sensor, and it's actually got a micro SD card reader too, if you ever want to do just a remote storing of data. And then I'm using, I think Brad mentioned the things indoor gateway, so that's down here plugged into the wall right beside me, and so we got that device. And then other things we would have set up is you do need an account on the Things network. I'll kind of show that login process and the account on my Cayenne devices, which will give us a dashboard of the data being sent across the network. So for that, now I'm going to stop sliding. I'm going to close this out. And so on the screen, you should see the Atmel Studio IDE, and that's what we're going to use to you know, program the board. I'm just going to walk through the process like we would do if we were in the class. So I've got a project. I'm going to open the project. And the project is up. So we're not going to, this isn't going to be a code demo. I'm not going to walk through any of the code. The only thing we have to make a change to this firmware is we need to add the application and network keys that Brad mentioned. So what I'm going to show next is, bring this over. So the Things Network is one of the LoRa network providers, and I already have an account, but if you would come in here and it's a, you can do some free devices and setup. So you would just come in here, create your account, and get it set up. But as I mentioned, I already have an account, so we will go over here and we will log on into the Things Network. And most of the activity is in the console. So here's the console you get from the Things Network, and we are going to create an application. So I've got a couple others in there, and maybe I'll show one just. So I've got another device back in our network closet that's set up to transmit, I think, every 20 seconds. And so what you can see on the Things Network is it's 11:15, and there was a packet that was just received. And in another 20 seconds, there should be another one coming through. But the packet that we're using is it's a Cayenne low power packet. And there's two channels. So we have the channel for the temperature, and channel 1 is for the light sensor value. The next, if you go into the Cayenne LPP, it'll define all these data, what each data packet is. But this, the 67 means it's a temperature sensor, and 65 is a light sensor value, and then this is the data from the temperature sensor, and this is the data from the light sensor. So like I said, you can monitor the data coming in from the device. But what I want to show you is how to create another application. So like I said, we're going to add an application. We can just call this, we'll call it Microchip _app, and we'll call it Demo Day R34. And down here, and these are some of the various handlers that the Things Network have. For the free ones, we use the one out west. Not application. Oh, I already have that. All right. Create that. We'll just call it Microchip Demo. There we go. Now it's created. So I must have had to use that ID in the past. So now we've got the application created. Now we need to add a specific device. And this is my eval board that we need to add to this application. So you come down to the devices and register your device. Once again, this is just a unique ID. So I'll just call this Office Demo. And we just click those little things. So you could actually define your device UI. We're going to let the Things Network generate that for us. And then the application key will be generated also. And here's an app UI that's been set. And we just register the device. So here's the device keys that Brad had mentioned. So the Things Network makes it pretty easy. We need this for our header file. We need to see it in the form of byte separated by commas. So we'll switch it to that format for the device UI, the application UI, and the app key. And then the other thing Things Network makes it very easy for is it just lets you basically click on here and it copies it to the clipboard. So with that, I will come back to this screen. We get to the header file. So here's the header file where the keys are stored, and here's our OTA join parameters. So I will, as I mentioned, I will copy these across into the application. And once they get these copied in, obviously this is probably not the safest way to have your keys that are just in the header file being stored. So I've got one of my teammates, Brian Hamill, is going to kind of go through a provisioning piece that provisioning piece of how to provide a secure element that provides these keys and makes the security much more safe and robust. So, and get the last one. All right, so I think I got all the codes. Whoops, that was wrong. I hit the wrong. Here we go. So 16. Make sure these are all right. Okay. So from that standpoint, then all you need to do is just do the build, and I will start the build process. And while the build is taking place, I'm going to go back to presentation mode. We're going to go build the code and get back to presentation mode. And I'll let Brian, I assume you're on and unmuted.
Hey, I'm here.
Okay, thanks, Brian. So Brian Hamill is one of my FAEs, and his specialty is the security products for the area. So with that, I will let Brian kind of go through how we could do secure provisioning of the network keys for the LoRa network.
All right, thanks, Mike. Yep. LoRaWAN relies on a symmetric key architecture, and we ask ourselves, how do we get a key? Well, the way we get a key is not in a very secure way. We get these keys by mail or by email, or somebody writes them down on a napkin. Anyway, they're printed out right in front of you. Sometimes in the development phase, we compile these keys right into the source code, or there's some kind of a manual entry process required, but the keys are required. Next. Authentication for LoRaWAN, said it relies on a symmetric key architecture. That means that there are shared keys. The same parent keys are shared between the node and the network. It's not really practical to use a public key infrastructure like we use in the web, because of the increased size of the transactions would impact the data capacity and the power consumption of some of these battery-powered nodes. So the LoRaWAN network uses two keys, two parent keys. There's the app key, which is shared between the node and the network, and the network key, which is also shared. Just make a note that the app key is used for authentication, and the network key is used for encryption. Those are two separate parent keys. However, the session keys are derived from these parent keys. So every time the node connects to the network, there's a new session key generated. And that same derivation operation has to happen on the node side and the network side, so that you end up with the same session key. So that node can authenticate and encrypt and decrypt data. So next. So the vulnerabilities are that these keys, in many cases, the parent key exists in the memory of the node. It's easily accessible. If someone wants to hack your device and figure out what that key is, they can probably do that. There are ways. So if someone comes into possession of your keys, they can essentially steal the identity of your device. They can counterfeit your device, meaning they can put their own devices on the network and use your service that you've paid for. They can provide counterfeit data into your application. So it's not a good thing if someone wanted to counterfeit your devices by copying your keys. They could even deny service to your device because they're using the key that you should be using. So next. So LoRaWAN 1.1 improved the back-end security. So it went to the 2-key architecture that I mentioned, which is better on the back end. You're not using the same key for the encryption and authentication. But they're still accessible. They're exposed to software, and the big problem that we have is getting those keys into the devices in a secure way, especially if you're not building in your own facility. Maybe you're building at a contract manufacturer, even in another state or another country, and you need your keys to be managed securely. So the supply chain vulnerabilities are immense here. Think about the product owner that generates the keys, the production site. You could generate keys there, and then these keys have to get registered in the network as well. So there are vulnerabilities between getting the keys into the device and registering the keys with the network. So when this key is copied, sent, and stored, there's no trust. That's not part of the LoRa infrastructure. You could simply upload a set of keys to the application server. Yeah, there's things you could do to make those more trustable, that they didn't get altered, like signing them or providing a hash or checksum or other message authentication code along with your keys. But essentially they're sent out in the open. So next. And again, this is both the app key and the network key have to be shared between the product and the network. And there's a big scalability issue there as well. So here's a summary of the vulnerabilities. Your root keys are accessed at your site, at the contract manufacturer. There's risks of counterfeiting, also scalability and setup cost in a contract manufacturer. If you're going to provision keys into devices, you have to have some kind of secure way of doing that in the back end. And of course, in the end node, you have keys stored in the flash of a node, and those could be gotten to using various attack methods on flash memory inside of controllers. So the challenge is getting a pre-shared root key into both the nodes and the network, and doing so securely. So how can we do this? Well, the Microchip solution, the secure element solution for this, we partnered with the Things Industries first on this solution. We also support Actility, who is another network provider, and working on some others. But the pre-provisioned secure elements mean that there's keys and other information already stored inside this little chip that you can solder on your board when you receive it from Microchip. We do the secure provisioning in our factory, and we bundle that with the TTI join server service. In fact, if you buy one of these chips, you get a year's service on the join server with the chip. So from the first time you activate it, the join server is like it's what makes everything happen when the node joins the network. And the secure element, if you will, it becomes like a cellular SIM card for the node, for the LoRa node, because it contains all the information needed to join the network. The join server also allows you to transfer your node to other networks.
Fine, how are you?
And can also
So we're all having a
rekey
text message
the node
chat about this
remotely.
new valet garbage service. And
Okay. All right, next. So in the situation where you have the secure element, the parent keys are pre-provisioned in the secure element. So you have the AES 128 key, the app key, and the network key in the element. You also have those exact same symmetric keys that are preloaded securely into the network, the join server. Um, this secure element is part of your product, and the join server is part of the network. So when your device comes online, it sends a join request. The join server processes that based on the unique identity provided by the device, which is also stored in this secure element. The join server knows which key to use to derive the session keys needed for your node to join the network. So this simple onboarding process, if you're a customer, you order our Trust and Go LoRa product for the TTI join server. Microchip prepares that order, ships it to you, and also provides a manifest file to you, which is important. You as the customer download the manifest file. Then you, as a customer, would upload that manifest file to the join server. Uploading the manifest file does not contain actual keys, but it contains identifiers that allows you, the customer, to claim the keys that are already pre-loaded into the join server. And the reason they're preloaded in the join server is because Microchip preloaded those securely for you. So anyway, it's a fairly simple process. You get the predefined part number, you prototype and code your application, and you can go to production. These secure elements are easy to use. We sell them in quantities of 10, minimum order quantity. It's connectivity and cloud agnostic. I'll talk about that just a little bit. And we have a short time to market. There's demo code on GitHub right now that uses the ECC 608 TNG LoRa part with the SAMR34 board that Mike was talking about. And you can go through this very exercise, and you can order from us for 10 units. Next. Just a little bit of a picture of what's inside the secure element. We do see in slot 0, there's the network key and the app key. These keys are 16 bytes, and that's a 36 byte slot. So both keys fit in the same slot. We have an ECC private key, which could be very useful if you're using the LoRa node on a network that needs a private key to provide, say, a signed token. Google's Cloud uses a signed token called a JWT to log into their MQTT server, and you could use this private key as the identity of your device. Moving further down, you have the app S key. That's the session key. These are session keys that are used. They are actually derived inside the secure element. So you derive from the app key or the network key to fill these slots. So you don't have to do this in software on your node. And furthermore, the parent key never comes out of the secure element. So you never compromise that, say, by bringing it into the memory of the microcontroller. We also have a join EUI, which is a full EUI for the LoRaWAN, and we have a repersonalization key, which allows the join server to rekey your device. IO protection key, which is a way of scrambling the data bus so someone can't sniff on the I2C bus between the controller and the secure element and figure out what's going on there. And finally, a secure boot public key, which can be used to validate the firmware running in your processor before you allow it to run. So again, if you have questions about this, be glad to answer.
I do have one question right here. What is the total hardware cost for basic PCBA, including secure element and annual recurring costs?
Yeah. Mike, you're muted.
Oh, sorry, I was muted and didn't realize it. So, so what I said from an annual reoccurring basis, I would check with like the Things Network or Senate or any of the carriers for that type of information, because that's kind of outside of our expertise. At the chipset level, and we're all apps guys here in the field. We do have a marketing person, Rami Koda, is on the line, but I would just, the parts are available on our Microchip Direct website. And if I remember, I think the SAMR34 is less than $5 in small quantities, and the module, I think, is less than $10 in small quantities. So, I mean, and what else is on the PC board? It depends on your sensor and anything else that you would want to do. So, but we've got a team here that would be happy to work with you on any of your designs and getting something to market. But not very expensive from a PC board assembly, and then I would talk to the Things Network for their annual usage fee. But as Brian mentioned, if you use a secure element, and I guess I didn't talk, the secure element those are very inexpensive devices, much less than $1. And one thing that Brian didn't add is that these devices are very tamper-proof, and they have a very high GEO rating, which means it's very, very difficult to ever get any of the keys that are inside the devices stored out. So that's why this is a very secure and robust, and provides a lot of confidentiality to your keys. So. Any other questions, Carolyn?
Yeah, thanks so much, Mike. I am not seeing any other questions right now. Again, I encourage you, if you have any questions, please do put those in the group chat. But right now, I'm not seeing any additional ones.
Okay. So thanks for Brian for going over that. Security at the very high level is relatively simple. When you get into the details, it gets a little more complex, but we try at Microchip to make it relatively simple. That's why this LoRa secure element, it's just a standard part, but it does a phenomenal job at protecting your keys. As you saw when I was copying those into Flash or into the header file information and just get compiled, you don't want your keys just sitting in Flash that can be accessed. And I was also remiss, I have a couple other team members on the call with me. James Schaffer is one of my apps guys that's specializing in the system software level stuff. And Keith Donadio is my wireless FAE. So, and a short commercial for Microchip. We have between myself and a counterpart down in Florida, we have about 18 field apps engineers in the Carolinas up through Philly and down to Florida and the Huntsville market. So we have a lot of apps guys that can support your requirements. So let me stop sharing again. Close out back to the demo. So we'll get rid of that. We'll bring back the Atmel Studio window. So you can see the build was successful. We have an onboard debugger, and so with the way this application runs that we built today, displays it out to a terminal emulator. So I will start a terminal emulator, connect to the port. And set the baud rate. And I don't have my video on, but so I can turn it on for a second just to show. So there's the board that we have loaded with the firmware, the I/O board. I'm going to just hit reset, and so I'm resetting it. It's the demo's already started, and we're sitting here basically as the application started. It already did the OTA activation, and it confirmed with the gateway that it has connected. So from that point, we basically have a device on a network ready to connect to the things network. So let me do a little shared screen here. And so as you remember, we created this application Microchip demo. We had the device that I created called Office Demo. And as I showed on the other, we had data coming in, and this one has received a couple bytes. But if I send, let me make this a little bigger. You see it. So when I issued the send data command, it came back and said the temperature on the board was 24.5 degrees Celsius, and the light sensor value, the voltage was 3.2, which equates to about 64 lux. And you can see at 1140, that data came back, and as we already described, here's the payload of the temperature value and light sensor value. So, and oh, we got an error. Oh, okay, let's try this again. All right, we're still, okay, not sure what happened with that transmission, but we are now seeing data come through, and you can see sometimes there's a retry, a couple of retries, third retry. So this packet is not making it through. And then finally it did. So, but, so that's what the thing network shows you. And you see the data coming through. And then from there, we want to, if we want to see that show up on a more of a dashboard that has a little bit better visual representation of the data, you add an integration to the device. And let me make this full screen so you can see. So I'm going to add an integration. There are a number of devices or options out there. We are using the Kai and My devices. And once again, you just give it a process ID. Let's just say Office Demo Day. And we just select the default keys and add the integration into the system. So now we've got an integration that once the device EUI is registered on the MyKai and My Devices site, it will, this data from the Things Network will pass on to the dashboard. So we need to get another, let's see, so bring this over. So you just go to the Kai and My Devices link. If you just Google Kai and My Devices, it'll give you a prompt that to create a new sign-in. You actually, down at the bottom of their homepage is a sign up for free access, and that's where we're going to go now. Back here.
Hey, Mike, what is the battery life for 10 data packets per day?
Good question. Maybe Ramya, do you know the answer to that? Have we done, in standby mode at 1.4 microamps, we could probably, depending on the size of the battery and all that, maybe Keith or Ramya can come up with that answer.
Mike, sorry, I missed the question. What was it?
What's the battery life for, was it 10 packets per day?
Yeah, 10 data packets per day.
Okay.
I am not sure. I just have the numbers on the sleep and the standby currents for the part itself, but I believe we have an application note which talks about the power consumption based on the data rates.
Okay.
I don't
So
know off the top of
Just to really answer the question, we need to know what output power, what data rate you're transmitting at and how big the payload is. But I think generally speaking, the peak transmission power at 20 dBm, and you have to look at the exact data sheet for the Microchip part, but it's on the order of 100 milliamps when you're in transmission mode, and you would have to times that times your on-air time, right? Which worst case would be around 370 milliseconds. It could be much, much shorter if you're at a higher data rate. And then if you turn down the output power, your peak current would be, I'm sure, 50 milliamps or less, something in that range. Again, look at the Microchip data sheet exactly. But that would give you the calculation that you need to actually come up with that. And then in sleep mode, as Mike said, right, that you're in the microamps, right? So it's really the transmission mode current that you need to model, and the time on air times the peak current during transmission.
yeah, so it sounds like if you had a duty cycle, this is probably a 99.9 something % off or in standby, and then 0.01% on. It's going to be relatively small, but if somebody, the person who answered that question, you can email me at michael.marks@microchip.com, and we can have some follow-up discussions and go through some of the use cases to get to an actual number.
Thanks so much, guys.
So now we're on the kind of the dashboard, and as I shared earlier, I've got this Mike's project, which is a board that's running back in our network closet. So it's you can see the dBm value is not small. We got a lot more link budget available, but it's around minus 60 dBm from the RSSI signal, and the signal to noise ratio is about 8.5 dB, and the temperature in the wiring closet is 22.5 degrees Celsius, and the lights aren't on, but there is a window that lets in a little bit of light so that you can see the lux value. And you have some settings in the dashboard you can change. If you want to read this in Fahrenheit, you can change that. You can actually set the number of decimal digits if you want to just look at if you want, so anyway, a lot of flexibility. So, but let's show how we add the new device that we created. So we want to add a new device, and Kyan has a number of different devices supported. It's relatively very, very large, but we're doing a LoRa device through the Things network. And as I mentioned earlier, we're using the protocol of Kyan LPP. So we get down to Kyan LPP, which is right there. And so the only thing that Kyan needs is just the device EUI. So we need to go back to the Things network and go back to the device. And we just want to copy that value, and we'll put that in here. So now we have the device for the one that we just added to the Things network. We'll add that device. And now it's waiting for data. So until we send data, we'll bring this down a little bit lower. And there is the data that came through the Things network to Kyan, and it's been displayed. And if I put my hand over the light sensor, you can see it goes down to 9 lux. And if I put the sensor close to the fan output on my laptop, which is glowing right now, you see that the temperature goes up a little bit and the light value goes up a little bit. So that, in a quick overview, is a pretty straightforward method for getting your LoRa device on a network and for doing testing. So as I mentioned, these eval boards have a couple expansion slots, so you could come up with some other sensor you want to add to. There are other devices available. You can go through microelectronics and get one of their boards that has the module on it. But anyway, so I guess the only couple other things to show is when this gets set up, it gets set up as just Cayenne LPP. You could give it a little bit more unique name. You can just call it chip demo type and save that. So now you got a little bit different name. And some of the other features you can actually, I've got demos. So these are a couple other modules that I have on the board. And if we want to add the one we just created, you can just drag it in here. It'll actually, maybe you don't care about the RSSI, you just care about the light value and you care about the temperature. You can add those. They should pop up. Oh, maybe it's again. Let's just grab them all. There we go. We only got, why didn't you get the other values? Oh, okay. Try this again.
Yeah, send it again.
Oh, okay. That's okay. Yep. Let's just send more data to get an update. Yeah, for some reason, we are not getting the. Let's just remove this. No, we don't want to move the widget. We just. Let's see, why are we not getting? Let's try this one more time. We send the data. Well, live demos, sometimes it doesn't do what you want it to do. So let me go back to just here. So we should be seeing data. And some data. All right, we got values back. Cancel that. For some reason we've got in the graph mode. I'm not sure why. Well, I'm not sure exactly why that happened like that, but we'll try going back to demo mode and see if we can drop this onto the screen. And we'll just grab all of them. All right, other than we've got, let's see. I'm not sure why we were in this mode, but one thing I did want to show you, so I apologize for the demo not going as smooth as I thought, but there are also trigger events that you can set. So you can come in here and if we wanted to call this trigger dark, and we want to use this device, and we want to say when the luminosity value is, let's just pick a number. We're up 60 normal, so say we go below 50. And you can have different notifications, and I'll just send myself an email. And we'll add that, and we'll save. And we'll go back to the demo. So if you send data now, you see that the luminosity value is about 64. If I cover the light sensor, now we're down to 4, and in about 10 or 15 seconds, I should get an email from Cayenne. And when that shows up, I'll show you what you get. And it hasn't come through yet, but it takes a little bit of time. It could be our slow network, Microsoft Office, whoever, but when it comes up, I will show you. But so that kind of ends the demo. As I said, this would have been a lot more useful if it was hands-on and everybody had a chance to play around with the boards and experiment. But if anybody has interest, you can contact me, and we can show you where to get the boards and the gateways and all that to get up on the network. The Cayenne just came through, so if I open that. So here was the, came in at 1154, channel 1, we reached a threshold of 50, and it tells you which device was connected to. So that's how you can set up notifications if you're doing any testing. So that's the demo. I guess somebody else was talking about cost. The Things gateway, indoor gateway, is relatively inexpensive. I think it's $80 if you just go to the Things network site and look at their products. I think it's $80 or $89 for the 8-channel gateway. And we've been using it for a while, and it seems to work very well. So that's all I got, Caroline. Any other questions?
Thank you so much, Mike. I don't see any here, but please, wonderful presentation. Again, yeah, it's hard with the virtual demos, but stay tuned for the next developer day. Hopefully we'll be in person, and you'll be able to play with those cool demo kits from Microchip. So thanks again to all of our speakers at the Advanced Mobility Collective, Semtech, and Microchip. We'll just enter the virtual networking half hour early. So I encourage all of you to turn on your cameras if you're comfortable with that. Mine's off right now because of bandwidth issues, but unmute yourselves, please. If you have any questions that we didn't get to earlier, I think we got them all, but in case, please use this time now to ask those, network with our speakers. Great presentations for everyone. So thanks again to all of our speakers, and for everyone who's joined all the sessions. Thank you so much. We'll be giving away this week's prize, courtesy of Microchip, in about 15 minutes. So please network until then, and then we'll announce that prize in about 15 minutes. Thanks again, Mike, and your whole team. Great presentation.
Thanks, guys. Thanks for Keith and James and Rami and Brian for supporting us. So. And Brad, it's always good to hear what's going on, and the number of nodes is very impressive on how many have been shipped so far from a Semtech radio perspective. There's a lot of LoRa out there.
Yeah, those presentations really complement each other very well. So great to have those back to back. Lots of great feedback on the group chat on the presentations. Very informative.
I have a question for Brad. This is a follow-up to the impact if my packet length exceeds the current data rate defined maximum. Am I to understand that the packet would be transmitted, but I would be, of course, in violation of FCC rules? Would my entire data packet be transmitted, or am I potentially going to lose data?
Yeah, so again, there's multiple specific limitations. So the chip itself, when it's running in packet mode, has a limited buffer size in it, which is, allows for like the 240 byte payload size, right? So the buffer's a little bit bigger than that to cover for the preamble and stuff like that, right? So at a certain level, if you're running the chip in packet mode, you're going to run to a physical limitation on how big a packet you can stick into the chip. So assume 240, 250 bytes is the limit. So does that answer a part of your question? Do you want to transmit something that's bigger than 250 bytes at a time?
Well, no, it's not that I want to. This is more for error checking. What happens if I, for instance, I need to transmit a packet that's a little bit larger than my current data rate. And it kind of goes back to the ADR as well.
Yeah. Okay. So for any modulation bandwidth spreading factor setting, that's gonna, again, if you look at that LoRa calculator, that's gonna come up with an on-air time. And so the chip won't, so let's say I had a 250 byte packet, but I wanted to send it, and maybe you're in a license band, you're not in the 915 ISM band. You wanted to send it at a high spreading factor with a really narrow channel bandwidth. So I'm going to share my screen. I think you guys can still see this if I do it. And I'm just going to show you the LoRa calculator. So can everybody see that?
Yep.
Yeah, thanks, Brian.
So, so you can see here, I can, a typical LoRa packet has about 13 bytes of overhead. So if I add 13 to say, 250, that gives me 263. So there you go, 255. It's gonna limit me out because of the preambles included in this. So 255 is the maximum the chip will take in terms of buffer size. So you can see based on spreading factor here, let me make this much faster. You can see if I use LoRaWAN settings, my on-air time to send the 255 bytes is 98 milliseconds. So that's fine with FCC, right? But let's say I want to transmit something with a much higher link budget. Maybe you're in a license band. So you can see, in theory, the chip will transmit, for 14 seconds, right, to get this one out. But you'd have to be in a special FCC license band to make that work. So the chip won't not transmit, right? But you as the implementer of the protocol, you need to be aware of your on-air time, right? Now, looking at your question from another dimension, let's say, let's pick one of the actual LoRaWAN data rates. This one, let me go one more. Oops, let me go this way. So this is spreading factor 10, 125 kilohertz bandwidth is a valid LoRaWAN data rate. But you can see here my payload at 255 has an on-air time that's way too big. So to actually use this, I need to drop my payload, down to 11 bytes or less, right, to make this work. In this case, I would have to break up my payload across multiple packets. So we do have customers that do this all the time, where they basically say, hey, I need to send 1K bytes of data, and I'm at data rate 2. That means I can send 50 bytes at a time. So you basically break your data up into multiple packets and send it 50 bytes at a time to make it work with your link budget and your on-air time limitation. Now, there are, in LoRaWAN, there is a fragmentation defragmentation library which can be used for sending large files. So there are some large file transfer examples in LoRaWAN, and yeah, you need to do a CRC or something to make sure you get all the transmissions to stitch them back together. There's also, by the way, there is a CRC on the actual LoRa transmission itself. So within LoRa and LoRaWAN, you should be highly confident that the existing protocol will make sure that you have a valid packet and you didn't have any corrupted bits or missed bits in any single transmission. But if you need to send more payload, then you can send based on your configuration of, again, the channel bandwidth and data rates and stuff, or you're hitting FCC, then you have to break the data into across multiple packets.
Right. Okay. Yeah, that answers the basic question. I guess where I'm getting at here is if I really want to be efficient and my packet is 10 bytes, for instance,
Mhm.
I might go to the lowest data rate. But the problem I have is if there's a MAC command request from the network and that response has to go back, now my packet potentially is larger than that data rate allows. Does that make sense?
Say that one more time.
If I've got a data rate of 0, which is 11 bytes maximum,
Mhm.
and my standard packet size is 10 bytes, then I'm okay. However, if the network sends a MAC request to my device, it's my understanding the device then probably sends a MAC response back to the network. Now, in that case, is not my packet length, does it not exceed the maximum?
I don't think, I think that's handled within the LoRaWAN protocol stack. Also consider the downlinks from the LoRa, and I'm talking LoRaWAN now, right? So I
Right.
think we're talking about the downlinks from the LoRaWAN gateway always use the 500 kilohertz bandwidth, which always gives you a faster equivalent data rate. So your worst case on the downlink, I think, is not necessarily the same data length, payload length as on the uplink.
Right.
And then I would have to honestly go look at the protocol stack to understand if there's MAC commands that are larger than your data rate. I think that's all built into the LoRaWAN stack. So if there are situations where MAC commands are bigger than your current data rates, the network server and the endpoint stacks are handling that reconstruction for you.
Okay. The implementation of the LoRaWAN runtime on the device end that I'm using adds my packet to the MAC response packet and sends both of them. And that's where I'm seeing the over max size.
And
That's okay.
Which
That's
device,
good.
Can you say which device you're using? Just...
It's a HealthTech device.
Okay. Yeah, so
But
the master repository for the stack is the LoRa GitHub repository.
Right.
So I again would have to.
Okay, that's okay. That's
go
fine.
Look,
That's good.
Yeah, go look here to make sure exactly. It's a great question, honestly. Obviously, you've dug deeply into this to go double check exactly what's happening in that scenario. But this is the first time I've heard somebody bring it up.
Honestly. Okay, you answered my basic question. Thank you.
Yeah.
Awesome. Any other questions?
Brad, this is Gopal. Good morning.
Hey, how are you?
Good. So I was having a question about the LoRa Edge. We put the gateway here in Charlotte. Some friends were asking if they want to do the asset tracking for their pet. The LoRa Edge has the GPS, correct?
It has a partial GPS in it. So let me show you a more detailed block diagram on LoRa Edge. Give me 1 second. And I'll open it up. So if you think about a GPS chipset, like a U-Blox GPS, for example, you break maybe what happens in the chip into two parts. One is actually the radio receiver part that receives the messages from the satellites, and those are demodulated into what I think is generally referred to as a nav message, which has kind of that core timing information coming from the GPS satellites. Then on like the U-Blox chip, for example, it has all the other computational capability to basically take that timing information received from the GPS satellites and actually compute a lat-long position. So it turns out that if you look at the energy profile of those two functions, the function to receive the satellite messages is relatively low power, relative to the task to actually do the compute part on the chip. So what the Semtech's LR1110 device does is it basically receives the nav messages on the chip. Obviously, that's required. The physical chip has to receive that information, but we don't do the compute function on the chip. we assume that the device is always connected to a LoRa network, and we basically take those nav messages and send them via the LoRa transceiver to the LoRa network, to the LoRa Cloud in the demo cases, and if customers want to, they can continue to use that for a production scenario. So we do a partial GPS. So what the Semtech Cloud does is it receives the nav messages, which are captured by the device, and it does the resolver computation in the cloud. And then the location result can actually be sent anywhere. So if you think about it, like if you're trying to track pallets in a warehouse or pallets on a shipping yard or whatever, the pallet itself doesn't really care where it is in most cases. It's, you know, you want to be able to visualize the pallet's location on a map. And so the lat long coordinate of that tracker actually gets sent from LoRa Cloud to usually the customer's application. So that's the app running on your phone, or the dashboard running on whoever's looking and tracking all these different assets. So it's a GNSS receiver. To get the lat long coordinate that you expect from GPS, you have to do a cloud-based algorithm to resolve the coordinates.
I see, that helps. So basically they have to use the cloud for doing this. And what was the pricing on that LoRa Edge? Are you guys open for some beta kind of thing for LoRa Edge?
Oh yeah, so the LR1110 is available. I'll defer you guys to DigiKey or some of our channel partners to get actual pricing. But the LR1110 product, if I can just find it quickly, is available, and there's EVMs out there. There's going to be a new development kit that's more of a turnkey solution, coming. So just stay tuned to announcements over the next few weeks. But you can get a bunch of basic information on the LR1110 right now. As you can see, it's here on the website. There's some really good app notes down here. And for initial evaluation, you could buy one of these EVM kits and start to do evaluation. This will allow you to sniff, again, Wi-Fi signals, and it will allow you to receive satellite messages. And if you follow the instructions in the kit, it will show you how to connect that to LoRa Cloud, which is the Semtech online service that would provide that lat long coordinate. You do not have to use LoRa Cloud. I would be clear. You can use the device by itself. For the Wi-Fi locationing, you can use like a Google's Wi-Fi location database or other. For the GNSS locationing, it's a little bit more intricate. There's not as many more kind of off-the-shelf options like there is for Wi-Fi. But for folks who are familiar with satellite, GPS systems, they could implement their own if they wanted to.
Thank you, Brad.
So you can go here to LoRa Cloud to learn more, and stay tuned. Like I said, there's a lot of stuff in the pipeline from Semtech on this that will be coming out, but you can start with that EVM that's available today.
That's really helpful. Thanks so much, Brad. Any other questions for Brad or Mike And thanks to everyone for joining today.
Automated driving, autonomous driving, and artificial intelligence and machine learning. And second, and equally important, it is not just a response.
All right, well, we will go ahead and get to the fun part of the day, which is the prize winners. So we actually have two winners to announce today. One is for the Amazon Fire Stick. That is for just attending this session. So the winner of that prize is Phil Tran. Congratulations, Phil. If you will please email me your address. I'm putting my email right here. I'll make sure that gets to you. And then the next big prize, and again, thanks again to the Microchip team for contributing to that prize. They are today's sponsor. If you would like to learn more about Microchip, please reach out to Mike or any of the Microchip team here today. Thanks to them again. And then the larger prize, this prize is given to someone who attended for all 5 weeks. So that winner is GoPal. Congratulations, GoPal. You are the winner of the 43-inch 4K smart TV.
Thank you.
Nice.
Woohoo, go GoPal.
Thank you. Thank you, Caroline.
Absolutely. Please email me your address and I'll make sure that gets directly to you. But thanks again to Microchip, Semtech, Advanced Mobility Collective, all of our other speakers and sponsors for all 5 weeks of Developer Month. Again, this month-long event series was created in part due to COVID, as we could not join in person for our traditional Developer Day. So thanks again to all of our speakers for being so flexible, for coming on Zoom and sharing their expertise. We're just very appreciative. You can find the recording from all 5 sessions on RIoT's YouTube channel. This one will be posted by the end of this week. And I encourage you to please connect with our speakers. They volunteered their time, took time out of their busy schedules to participate, and we're just extremely thankful for them. So thanks again. Awesome. Well, yeah. I like virtual meetings too. Yeah, it gives the ability for people to come together from all over. But hopefully we'll be able to get some of those live demos back. Awesome. Well, I'll leave it open for a couple more minutes before I end the meeting. But again, thanks to everybody for joining. Thanks again to Brad, Mike, the entire leadership team. And Todd's
Caroline, I'll send you my presentation, and I'll probably have a little lab manual at the end that if anybody wants to, kind of do what I did walking through, that'll help them out. So I'll put that all together and email it over.
Perfect. Thanks so much, Mike. And I know Brad said he was going to do the same, so you'll be able to find those on RIoT's meetup pages, all of our chapters. So everyone who signed up will be able to get a copy of those presentations, which is awesome.
Caroline, are you guys going to post a video of the session?
Yeah, so it'll be posted on the meetup page and also on RIoT, and I will make sure all of our speakers, I'll send you a direct copy of that once it's done processing, so you guys won't have to search for it.
Right now there's on the surface a 21% going to 28% tax change for U.S. corporations.
All right, well, looks like people might be getting back, maybe getting hungry, making some lunch or something, but thanks again to everyone. Until next time, hopefully we'll be in person for Developer Day, but thanks again, special thanks to Microchip for being today's sponsors, and really appreciate all of our speakers. Thanks, guys.
Thanks, Caroline.
Thanks, Caroline. You guys have a great day.
Take care, everyone. Stay safe.
Thanks.
Bye.